Welcome to the Ham Radio Workbench Podcast, your bi-weekly deep dive on technical topics of interest to the radio amateur. The boss is away, so all the boys of us will play, and yes, this is Vince. If this is your first time, thanks for joining us. We have over 251 episodes in our back catalog. You can find us on our website at www.hamradioworkbench.com. You can connect with us on Facebook, on the Ham Radio Workbench group. You can connect with us on Discord at our new Never Expires Discord link found on the hamradioworkbench.com website. You can find us on Brandmeister Talk Group 31075 and All-Star Node 55915 and now Ham Shack Hotline extension 94156, which is connected to our All-Star Hub.
Hotline's dead.
Ham Shack Hotline is dead.
All right. Well, I did
Blooper
not
number
know.
one.
I did
Leave
not
a
know.
5-second pause.
No, I'll just start it again. It's easier.
Is it though?
It really is.
With
In
that
5, 4. Welcome to the Ham Radio Workbench Podcast, your bi-weekly deep dive on technical topics of interest to the amateur radio operator. If this is your first time, thanks for joining us. We have over 251 episodes in our back catalog. You can find us on our website at www.hamradioworkbench.com. You can connect with us on Facebook, on the Ham Radio Workbench group. You can find us on Discord with our new Never Expires Discord link found on the hamradioworkbench.com website. And you can find us on Brandmeister Talk Group 31075 and All-Star Node 55915. Now, the astute listener will note this is not George's voice. Yes, this is Vince, VE6LK. George is away, so Vince will play, and I get to interview our guest today. And I'm frankly very super excited about that, because on today's show, we are talking about QRP Labs with Hans Summers, Golf Zero Uniform Papa Lima. Hans was licensed in 1994. He became interested in ham radio in his university years when the chair of the Ham Radio Society was sitting beside him in class one day and introduced him during that class time. Hans then started his website, hanssummers.com, built his first transceiver in 2002. In 2009, he was invited to Hamvention and the QRP ARCI Hall of Fame for all of his great work on his website. You should really go visit his website. There's a ton of great stuff there. And in 2010, he produced his first kit for Weak Signal Works. QRP Labs kits really evolved from that point. Hans, good evening, good afternoon, and welcome. Thank you for being here.
Good evening. Thanks for inviting me, Vince. Pleasure to be here.
Awesome. And on today's show, we also have Mike, VA3MW. Hi, Mike.
Hello, good morning, afternoon, or whatever it is, wherever you are.
That's great. How are things in VA3 land?
It's snowing today, so it's Sunday, midday, unusual recording for time, which means I won't fall asleep by the end of the show, hopefully. And we had about 3 inches of snow, and then the polar vortex is going to hit. It's going to get cold.
Polar vortex. Okay. I wonder if that's related to polar modulation. Maybe we'll find out a bit later on.
What a setup.
On today's show, we also have Mark, N6MTS. Hi, Mark.
Hello. Weather here is 75 Fahrenheit. Nice and
That's
warm.
rough.
Yeah, it's a rough time in California.
Oh, terrible winter you're having.
Terrible winter.
I'm so sorry for your
I
luck.
almost had to put on a jacket the other day. I mean, that's just unheard of.
What?
Oh.
That's crazy.
Oh, I have been working backstage for a local production at our local theater that my daughter is in. And when you're backstage crew, you have to wear long pants. I am never seen with long pants. I am always in shorts or a kilt. And they made me put on long pants for this. And I was sweating like a horse. Yes,
Yeah.
It's December. Yes, I'm in a heavily air-conditioned theater, and I'm still sweating like a horse.
Oh, my. And they were black slacks. No,
They
no
were black
less.
slacks, yes.
Absolutely. Yeah. Black slacks, black shirts, black gloves, black hat.
Yep.
Yeah.
Long sleeves as well, which I also never wear.
Yeah. Yeah. I don't miss those days at all. And on
But I do
today's
love.
Sorry.
Excuse me. One thing we've got Hans representing QRP Labs, and we've got Mike representing Flex. I feel like we're going to have a Sharks and Jets moment with the polar modulation radios.
Let's just wait and see if we get there. Today's show, we also have Thomas K4SWL. Hey, buddy.
Hey y'all, hope everybody's doing okay.
How's things?
Things are going well. We're expecting a little snow tomorrow morning, and I think temperatures are going to get pretty chilly for us too, but not anywhere close to what Mike's going to experience. And we're actually heading out to the coast of North Carolina for a good week or so with our daughters, and it'll be a chilly time at the coast, but it should be really nice. Planning to do quite a lot of on the air stuff, probably a lot of parks on the air and worldwide flora and fauna, that sort of thing, while I'm out that way.
Right on. Well, very good. Well, from an announcements perspective, power strips are back in stock at DigiKey. Go take a look for part number HRWB-101, and you can get your power strip delivered to you through the magic of DigiKey. I have used them a lot lately. I had kind of a fun customer service experience with them this week. Something I ordered went up in price quite a lot, and I didn't notice it, and it delivered to me, and they allowed me to return the $110 connector and instead substitute it for an Amphenol connector. So they were very good in their handling of me. Great customer service at DigiKey as always. So with that, let's get into a round of what's on your workbench, what you've been up to lately. And Hans, as our guest of honor, we get to start with you today. So what's on your workbench?
You should start with everybody else so I see roughly what they say and for people not familiar.
Well,
I
well,
mean,
well, we could certainly do that. We're pretty flexible around here.
Yeah.
how long would you like me to spend? My workbench is very, very full of stuff, but not very much of it has actually been worked on for quite some time. So
Oh, none
we
of us know
actually,
anything about that.
No,
No, not at all.
it's more of a
most
question of what's not on my workbench. So
we would be
we
interested. We would be interested in anything, honestly, that you're working on, just like for your own ham radio purposes. Like what's your shack or what you're planning to do. We'd love hearing about that from you.
I really haven't done anything on my own ham radio purposes for too many years. Every single waking moment, I
Mm.
can't even keep up with all the QRP Labs requests and emails and help desk tickets and manufacturing and procurement and everything. So I'm kind of surrounded by all these half-built projects. The workbench hasn't been tidied up since we moved here about 4 years ago to this particular place. And I'm kind of surrounded by all this stuff that I really would love to work on, but every day is taken up with all the QRP Labs stuff, and
What
I
would you
keep
work
saying,
on if you could?
well, I've always loved working with tubes, and I have
Mm.
had a project with a Greek radio amateur friend to make an 807 transmitter
Hmm.
with an 807 tube and then a separate tube as the oscillator. And every winter for the last 5 years or so, we've been saying, oh, we must finish it this winter. It'll be a great winter project. And we never ever get round to doing it. I'm kind of rather enjoying WinLink at the moment, so I don't know if I can actually just turn around my camera and show you. Um, I have this second screen up here, which is a Raspberry Pi. It's a little 10-inch monitor I have with a Raspberry Pi, and the QMX Plus is there on the right. And I use that Raspberry Pi with WinLink, and I kind of enjoy that at the moment. But as the propagation is kind of variable, and in the wintertime on 20 meters, and my nearest station is 635 kilometers away, which is quite close for 20 meters. So I sometimes get through to him and sometimes not. And so another project I have is a Romanian friend gave me one of these Chinese 180 watt linear kits, which probably really produce about 50 watts, but I'm instead of 180.
They're
And they had
100, they're
zero
180
instructions.
ILS if lightning strikes.
Ah,
And so I need to finish that off so that I would have a more reliable connection with the European WinLink servers, which are a bit too far for me at the moment. And then, of course, behind me, I've got this great StepIR DB18 antenna, which I need to put up. And this has been sitting there for the last 2 or 3 years. I don't know if you know about it, but I'm actually responsible for producing StepAR's front panel of the controller, and I migrated that across to an STM32 processor a couple of years ago, and I produced that for them. And as a result, I've got this DB18E 3-element beam StepAR antenna, and I bought myself a Yaesu rotator, and all I need to do is put the tower up and find someone who dares to climb up it and somehow survive the onslaughts of the neighbors and the wife and the local police and the municipality and whoever else cares to complain about this gigantic thing. So I really, this winter I'd really love to get that antenna up. But I've said that for the last couple of winters. So yeah, there's not very much going on my workbench, but I wish there was a bit more time to spend on some of these things. And the antenna work, the 100-watt linear, the tube stuff. I have tons and tons of projects. Those are three that just come to mind right now.
So I got stumbled for a second when you said you bought a Yaesu, but then you said rotator. Is it true that you still have never operated a commercial radio? You've only ever operated, or maybe it was owned, homebrew gear?
Yes, that's perfectly true. Yes.
Yeah.
Wow.
I should take it and come back a little bit and show you my situation here. This is all
for those listening
stuff.
on the audio podcast, you'll want to go watch the video episode of this to appreciate Hans's workbench fully. Please go ahead.
So right at the top here, this is the I don't know if this camera is really working.
It looks like it locked up again.
Do you see that? It's locked up again.
We're back at Euroscope, which I think is
I
your...
don't know why it shows that. So maybe I shouldn't try this. Oh, there we go.
So
that's the original radio I had my first ever QSO on, which was actually a tube transmitter and a separate receiver that I built. And but yes, absolutely everything is homebrew. I don't own any commercial transceivers. I did operate a commercial transceiver. I was invited some time ago to join a special event station at Patara, which is about 2 hours drive south of me here in Turkey, on the southwest corner of Turkey. And it was one of the first radio stations in Turkey in, I think, 2013, at the end of the Ottoman Empire, as a huge, they would have had huge masts set up there. And they had a special event station to commemorate that. It was blown up by the Italians, I think, in World War I. And around 2018 or so. But they had, for some reason, a special event station, and I was invited to go along and observe that. And all the operators of this equipment were all SSB operators, and they had no one who could operate CW. So they told me to sit down and operate. And of course, I'm sitting there with some massive icon with millions of buttons and knobs and trying to figure out what to do to make it work. Luckily for me, as soon as I keyed down, the entire generator system shut off. They had some kind of common mode feed line current issue with their setup there, and so there was too much RF around, not enough grounding, and so it just shut down the generator. So luckily for me, I was saved from some embarrassment. But yeah, it's perfectly true. I somehow have no wish to own any commercial equipment, and I like building my own stuff and designing my own stuff. Sometimes it does leave me at a disadvantage because I need to know, when I'm designing the firmware and the functionality, I need to know what people expect. And a good example of that is that my original CW receiver was on lower sideband. It was for 80 meters and 40 meters, but CW operators are typically on upper sideband. So I was tuning that in reverse to what everybody else is used to, and I didn't know. I had no idea.
Yeah.
But come 2017, when I was designing the QCX transceiver, the first QRP Labs transceiver, and I had to look at how all these pieces of functionality were expected to work, like dual VFOs and RIT and split operation. I wanted to implement all that, but I realized I never used any of that because all my equipment is simple homemade stuff.
Yeah.
And so I had to try and figure out what people expect. So in that way, it's a disadvantage, not owning any commercial stuff.
I will point out that you are a definition at this point, right? Like you have your own UI. It is now the QRP Labs UI. Like you better not change it because everyone knows how all of your radios work.
Yep.
Right. That's true. Yeah, they do. The UI and lots of the functionality and the way it works is inherited from transceiver to transceiver. So,
Yeah.
I'm often inheriting code and concepts from one to the next.
So, Hans, I'm curious, like your the tube transmitter that you're talking about, is that were you working with Costas for that SV 3ORA?
Not Costas. I know
Not
Costas very
Costas?
well, and
Okay.
we email each other quite often. We've been friends for a very long time, and he has a really nice website and QRP.gr, I believe it is,
Mm-hmm. Mm-hmm.
and lots of projects on there that are really inspiring. No, this is another Greek operator. I can't actually remember his call sign off the top of my head. I should try looking it up, but no, it's not
Good old what's his
Costas.
name?
Yeah,
Well, I was curious because I know that Costas, I knew that you knew him, and he had at one point, developed a little 8 component high power, like I think it was 40, 30 meter transmitter
yeah,
that was really simple. And he called it like an emergency transmitter. It could get you on the air
right.
really quickly. But it's a
And
really
I built one
elegant,
of
simple
those.
design.
Yeah.
You do? Okay.
I built one of those and I wound the coil on an empty reel of solder. And
Oh,
then all the other few components, like I bolted some connectors onto the ends of this reel of solder. I have no idea where it is, but somewhere around. I just, yeah, it was fascinating. He does a lot of really interesting stuff.
hmm
Um, he also has some other sort of stuff on the website about homemade CPUs, which is another sort of niche interest that I have, designing your own CPUs out of discrete logic. And he has a page on that as well from some time back. Yeah,
Yeah, he's a really
great
clever
guy.
guy.
I've been watching a lot of YouTube videos on that sort of thing. Ben
Hmm.
Eater,
Ben Eater,
yeah, has been doing a series
yeah.
on. I can't. Is he doing the whole CPU from discrete logic, or is he just building up the computer with
No,
a
he did
on
the
a
whole
breadboard?
CPU. Well,
Yeah,
he's got a number of different projects. He's got a project with a 6502 microprocessor, and he's
okay.
built various peripherals for on breadboards. But he's also done a complete CPU from discrete logic.
Yeah,
And this is something that I wanted to do for the last 35 years or something, going way back, and even before there were any of these internet projects or
yeah.
YouTube videos or anything. But yeah, it's a huge amount of time that would take. I have some things I'd like to do, but
If you ever want to learn what's going on under the hood in a CPU and how, machine code instructions get translated into hardware gates and flip-flops and states and everything like that, go watch one of these video series. It's fascinating. And Ben especially does a really good job of explaining what all of that logic, what all of those chips on the board is doing and why it's
right.
there and kind of the both the high level and the detailed level. They're wonderful. They're super
And he
fun.
does everything on these breadboards where you plug in all the little colored wires and everything gets connected up.
Yeah,
I've used those breadboards long ago, and I no longer use them because you just end up with a dirty connection or something, and then nothing works, and you never know why.
yeah,
And so, I'm amazed that he's able to make such a large project with so many breadboards wired together actually work reliably.
I agree.
And if I ever do have time to do something in that direction, I won't be using breadboards. I'll solder everything together, even though it's harder to change because I have had issues with reliability. But
You ever played with wire wrap?
I have never
Ah,
played with wire wrap. Yeah,
oh
It is
God.
old technology, but it addresses all of these. It's easily changeable and it is very solid connections without needing solder.
I think Mike had a conniption when you said wire wrap. Why is that,
Yep.
Mike?
You remember the entire Toronto FM Communication Society repeater system here in
Sure.
Toronto so this repeater system to give you some, and this is how I met George when we went to retire. This system ran on a 6809 or is it 68HC11, one of those two. And it would control, it has 16 matrix audio switching. So they
Okay.
had a whole bunch of receivers and a whole bunch of transmitters, and then you would code them into repeater pairs. but it also meant you could bridge or link any ones you wanted together in any combination or mixture. There was no other repeater controller like this. It was written up in IEEE. That's in the day.
Neat.
The whole thing was wire wrapped, and we took a lightning hit in
Oh,
early 2000s. And Nigel, V3ID, to his credit, debugged it thanks to being wire wrap and put it back on the air.
Oh, wow.
And
it's bonkers.
I don't know how many miles of blue wire were in this S100 bus type card.
Yeah.
And there were multiple cards. So you remember V3RPT when you were here,
Yes.
Vincent, and
Yes.
this was a very wide coverage, heavily jammed repeater in its latest days.
Yes.
But yeah,
Oh, my.
there's still the only thing that ever came close to performing like it did was the Sierra Systems repeater controller. George's credit. So
Yeah.
anyway, that's my nightmare. It's like when you're talking old technologies or your work past from 20 years ago, and somebody brings up some company that you've mentally blocked from your brain.
Yes.
And they go, oh, and then all the nightmares have come back, right? So anyway,
Yeah.
that was the moan.
I was sort of expecting you to say something about a core memory card in some old
Yeah, in
System
Saber.
360, but
There's one over there.
Yeah.
I've showed you guys my core memory
Yeah.
cards.
yeah, indeed. Hans, anything else on the bench you want to share with us?
Well, what would be interesting? I've got this CNC machine, and I had this great intern during the summer, and one of the projects he helped me with was this CNC machine. And I wanted to use it for etching PCBs, and I don't know if I dare pick up this phone and try moving this again. Change the camera. So you can see here,
Oh, okay.
it's just a low-cost CNC machine, and I wanted to use that for making PCBs. And at some point, I thought I'd be able to make prototype PCBs, and it'd be much faster than ordering them and waiting for the delivery and everything like that. And then I didn't do anything on it. The PCBs it produced were such bad quality that they were absolutely unusable. And so I realized I have to do some upgrades. I have to get a sharper cutting point and the correct angle and a faster, more powerful motor and a speed controller. And Jem, my summer intern, he helped with installing all of that and getting all up and running. So we actually did a low-pass filter board, one of the simpler boards. Now, by this time, it kind of all became pointless because now my boards are all 6-layer and 6 mil traces and things like that. So it's no longer something. I'm just trying to turn it around again. It's no longer something
you can do at home.
It's not something I can do at home anymore. So it doesn't really help me anymore anyway. But who knows? Maybe if I ever get to my TTL Logic computer, I can build the circuit boards with that thing, and that'll be a fun project in many ways.
Well, in that regard, let me recommend Usagi Electric, who also makes his own CPUs. He made what he called the UE1, which was out a tube CPU, and he mills all of his own boards out of single-sided copper clad, and he uses a giant.
I'm familiar with his channel, but I wasn't aware that he did CNC'd his own board, so I have to check that.
Yeah.
Thanks.
Yeah.
Well, very good, Hans. Well, Mike, what's on your workbench?
Well, this week, there's been some station maintenance. So the station was used for CQ Worldwide, SSB, and then Tony V3RZ used the Aurora, the AU520, for CQ Worldwide CW, and it worked famously, very well. And then again, he used it for 160 contest, which was this weekend, so it gives you an idea when we're recording. But in the middle of the CW contest, I get a text message, and Tony's using my station remotely. He's 200 kilometers away, and he did a nice write-up, and it was just like being there. But I get this text. It goes, the beam has stopped turning.
Oh, no.
Okay. So these things happen, right? It's a mechanical thing. I have no problem with rotators. I've been taking them apart. But so I drove up on Sunday morning, and I was nothing better to do. It's an hour and a half, and I'll go have a look at it. And it's snowing, and I still climb the tower. I can hear all you guys yelling at me carefully, double lanyard, crawl up the tower, do all the debugging on the ground I can. I go, oh, still not turning. Well, I wonder if the thrust bearing has failed, because we beat the crap out of it the week before, but I've never blown up a rotor. And so I get up to the top, and fortunately this rotor, I don't think I'll throw the name out there, or we can, because it happens. I pop the cover off where the wires are. If you know the rotor, you know which one I'm talking about. And there's a whole bunch of gold dust sitting in there, and I thought I was rich for a minute, but of course one of the gears has destroyed itself.
Oh,
And
Brass dust, I
it's
assume
snowing
you mean.
heavily, and I go, okay, well, it's done. And I quickly try to turn the beam with my hands, and it's pointed at 90 degrees. And I went, not thinking so straight, like, okay, I'm done. And I get off the tower and call it a day. So I typically, driving home, and you're working the problem in your head. And
Sure.
you go, well, you idiot, you should have at least loosened the beam and turned it to 45 degrees so it's pointed at Europe, because that's where it sits most of its life from my part of the world, in case you want to work somebody in Turkey as an example. And it's a stepper, so you can reverse it. So you're in reasonably good shape. You can contest for quite a while. So this goes on for a week, and I've got pictures of it, and I'm sending, one of the local guys, manufacturers around here, and they respond right away, and they go, yeah, sadly, that's, you got to take it down. And that's okay. I've designed the rotor to be removed from the bottom without having to lift the mast up or the beam and put a gin pole up. It's 20 minutes of work the way I designed it. And even my hand, it's not a ham fork or the tail twister, because it was designed to slide out sideways if you had a problem, and a replacement put in. You can tell that I've had half a century of dealing with rotators, because they freeze up or whatever. So during the week, I thought, I'm going to probably need a spare motor, but wait a minute, I bought another one of these a year or two ago at a great price, and I thought it was the elevation version. And I thought maybe I could just rip the motor out of it. And I go get it, and it's not an elevation motor. It turns out it's the exact same rotator I have.
nice.
So got a hot spare, right? One is done.
Yeah.
I fit the bill. So I think you guys are giving me crap about that. Because the group here gets pictures of pretty much everything I do. So yesterday was Saturday. I got a whole mission in my mind. It's one of those rotors where the cables all run down through the middle of the rotor, so you don't have to worry about getting caught up or anything. But it does mean if you need to swap out the rotor, you need to somehow take the cables apart or come up with an end. And backfeeding them through the mast is the last option you want, because it's far from trivial in December. And you're dropping wires down, like bolts with strings on them down so you can get a chase line through, and you're up and down the last 10 feet of the tower multiple times. And if you climb, you really want to park and only move when you have to. So everything is thought out very analytically. I'm going to go to the rotor level. I'm going to work there. I'm going to go to the top, do what I have to do, and maybe come back once. Because amateur rotors don't have full fall retention climbing lines usually. And I free climb. You can yell at me now, because I think having to clip every 2 feet is actually more dangerous than me. But I've also been climbing since back in the day, when you're the 14-year-old ham operator that shows up at a club meeting, and you go to the repeater site for the first time.
Monkey bars.
They go, look at you, and they go, here's the belt. Can you go up and water, check the connector for water?
Yeah.
Of course,
for sure.
you would never get away with that today. And so I've climbed my whole life, so I'm pretty comfortable. But I only climb my own stuff now, mine and one other person's. So I go up yesterday, and I thought, okay, going to climb. I'm going to do a proper reconnaissance, which I didn't do last time, and it's still snowing. So I get up to the top. I clip in. I have a beautiful DBI Sala harness, and I'm comfortable. And I've brought my 11/16 wrench. People who use this rotor are quickly going to figure out who makes it. And I undo all the bolts, and I then go up to the top. I wanted to see if I could turn the beam like normal. Now, the Samsung tower I have, which is, I don't know where they were popular. They're certainly popular in Ontario. Has a plate, and the the thrust bearing on top is not ball bearings. It's actually a brass on brass race. So you just keep it greased and it just spins beautifully. And there's no, I don't know how many thrust bearings I've seen where they start to fall apart and then you end up, it doesn't turn and it's a pile of dust in there. And you got to take the mast out to change them.
Yep.
So this
Huge
is
pain in the ass.
like a huge pain in the ass. This is a brass on brass, the race with the faces are horizontal. So they take all the weight. There's a bunch of grease in there. And you can, in the summertime, you can grab the mast and turn it by your hand. But I think it was just a little cold. And we use white, is it lithium fence?
Lithium.
On rotors. Lithium up here in the Great White North because it's good to minus 40 Fahrenheit or Celsius. And it's never let me down. So I had to climb up and turn it. So the beam turned normally. So that was good news. But I did mean that, okay, I got to come back to the rotor. And I thought, and it's a little foggy, so the air temperature's not that cold, minus 2-3 Celsius, but it's 100% humidity. So you can't work with gloves off in 100% humidity. You can at that temperature if the sun's out, because the moisture is not evaporating from your hands. And so the goal was to put a junction box up here, cut the stepper wire, which is 12 wires, 4 for each element. There's an AB antenna switch, so that's a pair of wires. And then the pointing on my rotator is a 403A flux gate compass. So even, I don't have to count pulses or anything. It tells me where the beam is.
Right.
And it works wonderfully. I love it. I wish all rotator solutions used a proper compass on the boom.
Sure.
So it doesn't matter if it's freewheels or whatever, or breaks free, you know where it's pointing. That's actually a LAN cable, but it uses 4 wires, and I'll probably just cut it and crimp on some RJ45s and put in a coupler. But of course, I need to put a small junction box up there just to keep everything mostly dry. So the idea with the stepper is the most complicated one. You know that George has got me into using ferrules.
Right.
So I was
He's
going to
got
cut
many
that
of us into using ferrules.
Yeah. And ferrulize these each of these 12 wires. Oh, I can't walk and talk away, or talk and walk away. And then I found on Amazon these spring-loaded crimpy thingies, which have arms in them, and they fit the ferrule at the size I want to use beautifully. So I have a nice, beautiful ferrule connection. And then I can jam in these, maybe I can get the name while we're talking here, and easily just fit those together. But then the other beauty of all that is it gives me an incredibly excellent point to debug problems. And
right, of course, because you can get a probe tip on the ferrule pretty easily enough, right?
Yeah, and they're called... You missed my fingers as I keep talking for a minute. They're called these. Who knows who makes it? But it's like the lever wire connector, 1-to-1 inline electrical connector, and it's a spring-loaded clamp down, and it'll do from 28 to. I don't know what it's called.
Well,
that name isn't in here.
Spelled Wago if you're American, but I think they're pronounced Vagos because they're German. The kind of the lever clamp down electrical connectors. They're used in house wiring a lot here in the States.
I'm going to share the screen, then Mark can back me up. And they do 28 to 12 gauge.
Yeah, they look like a Vago for sure.
Yeah, they're similar concept. That's a different design, but yeah, very similar concept.
Yeah,
So
you lift the lever,
of...
you jam the wire in the hole, you push the lever down, and Bob's your uncle.
Yep.
So they fit right here in the hole of the ferrule just beautifully. So that will end up being in the box, and I think I'm pretty quick. I could probably ferrulize 24 wires in about 10 minutes.
Yeah. I just recommend that you go read up on the recent announcements of, what was that ship that ran into the bridge about a year ago?
Oh yeah. Was that what they were using?
Well, it wasn't that clamp on, but it was because of improperly installed heat shrink on a crimp-on ferrule that made the jacket around the ferrule larger than the hole it was supposed to go into. And so the ferrule connection was poor, and it caused power surges or dropouts or something. And that's what made the boat lose its control and slam into the bridge.
Wow.
Yeah, I read
So-
that. And it wasn't the first time, right? They had been chasing this problem for some time.
Yeah.
It sounds like they used
And-
some of that cheap ass heat shrink that I was dissing on during the holiday edition of the show.
It was
Yeah.
definitely the improper application of the heat shrink. It was covering more than it should have, and made the diameter of a piece that was supposed to inset not be able to inset.
Wow.
Yeah. So I like these because they all clip together like power poles do in a stack.
Right.
And then I could mount them if I wanted to. I'll the secret, somebody asked us on Facebook today about something, but the secret of waterproofing anything outside in the ham radio world is
Do it in
make it
winter.
hard for the water to get in and easy for the water to get out. So
That. Yes.
yeah.
yeah,
And my proof to that pudding is a long time ago at our contest station, long before they had internet out there, we were war chalking to try to get DX cluster spots. So it's a very rural area. So we had a WRT54G router, the Linksys one, running DDWRT,
Of course.
stuck up in a cereal box from who makes all the plastics? It was a brand. It's
Hammond?
like saying Band-Aid. Pardon?
Hammond?
No, kitchen stuff.
Rubbermaid, Tupperware.
Rubbermaid, a Rubbermaid container.
Rubbermaid.
It just fit perfectly, and then we snuck out a cable to a big 20 dB gain antenna, and some poor guy would have to go up there, and we'd sweep the entire lake until we found an open spot at somebody's house, and we found a guy. We actually drove around and found it. It was about 6 kilometers away. And that was our link for DX cluster spots. This is in the,
So, like, you knocked
This
on the
is-
guy's door and said, "Hey, neighbor, we're 6K away. We'd like to borrow a little, like a cup of Wi-Fi."
almost. We never knocked on the door.
Oh, it was
So
open
here we are remotely
Wi-Fi.
connecting to some poor guy across the lake. And but this WRT54G was in this box with no bottom on it, or just the serial, and it was wide open at the bottom. It ran for 8 years. We never touched it
Yeah.
Yep.
until the
I
guy
had
changed
an-
his router.
I had a WRT54G in my crawl space where it would get up to 120, 130, probably 35, 40, 45 degrees Celsius. It would just get really bloody hot up there, and it just kept running.
So, well, the other thing is, once we got in and looked at it, we were looking at it and go, this guy should really update his firmware. So we updated his firmware remotely. We this is in like early 2000s, I guess. We what else do? We optimized it a little bit. We trade with some, dropout timing because we had to deal with path timing. So we had to extend some of those numbers, and we were getting a solid meg out of it, which was all we needed for, packet cluster. That's when the cluster was still on packet radio.
Yeah, I was gonna say you need way less than a meg for a packet cluster connection.
And that's all we had for anyway, it worked great. And
Until
eventually
he locked down his
had,
Wi-Fi.
Yeah, you never knew. Or
Yeah,
her, or whatever.
yeah,
But we never abused it. And it was like 3 times a year we used it.
Right.
Now, Ken's farmhouse in the middle of nowhere has gigabit symmetrical
Oh, my
fiber.
gosh. Oh, I don't even want to hear about that.
I'm in a city and I don't have that.
I
wanna
don't
hear
even have
about
it, and
that.
I'm in the city.
I
So,
don't want to hear about that.
I'm in
So
the
that's
city
what's
and
on my
I don't have it.
workbench.
I've only got 175 megabits. Thanks, Mike. Hey, Mark, what's going on? What's on your bench?
Not so. I was
Okay,
it was
I'm
only
done
me and Mike, do you have
just cut
anything
me
else to
off.
talk
Just
about?
go. No, just cut me off. I'm done. Go ahead, Mark.
Mike, I'm sorry. I thought you said you were done. That's what I thought I heard.
Maybe I did.
Mark, go ahead.
Hans, you get the idea how formal we are here?
Oh yeah. None of this gets cut out, just to be clear. Yeah. Anyway, so not my workbench, but one that I'm very interested in. There's a hand named Caroline K1EFR, who has been pretty active in the OHIS community on our Discord, and she just released and is now selling a what she calls the KISS radio or OHIS adapter. Keep it simple, stupid. It is a very small, very compact, very configurable radio adapter for OHIS. So you can connect it to your radio on one side, and it will adapt whatever your radio connection is to an OHIS socket. Where it looks like Vince is copying and pasting that right now into our show notes. But the Uncreatrix, UNCREATRIX.square.site is the URL to buy her adapters. I've got a couple on the way already. I think she's doing them in batches because she mentioned that the first one's going to be available in January, if I'm going from memory. But for me, this is exciting because this is the first case of someone else building an OHIS adapter, which is suggesting adoption and interest from more than just me, which is good.
Woohoo.
I want there to be as many people out there making adapters as possible. And I've got some other conversations that are going on that might hopefully lead to some more of that. So I'm very excited to see that happening.
That's very cool.
Yeah. The other thing that I talked about on the last episode that we only recorded a few days ago. So we're recording this pretty early. This is the morning of December 7th, a day that'll live in infamy. But last I spoke about it, the Cornell Alpha solar sail project was happening when we were last recording just a few days ago. It is now pretty much done. Unfortunately, the TinyGS stations didn't receive a lot. The downlinks they did get were from TinyGS stations that had high gain antennas on rotators. They didn't know the exact TLE, the 3-line elements, the orbital parameters for the satellite, but since it was launched from the ISS and did not have a lot of velocity when it was launched, the TLEs were going to be pretty darn close to the ISS. So the high gain antennas were just pointed at the ISS and hoping to catch enough of the solar sail to be able to get those downlinks. And so they downlinked, I think, 30 or 40 some odd packets, and they were kind of in bursts. So there were, times when the conditions were good, and then other times when the conditions were bad for the satellite itself. Unfortunately, I have not seen a report from Cornell. I don't know whether they've released one and I just haven't found it yet because I've been super busy, or if they haven't released it yet. But so we don't know how the mission went. The silver lining I'm taking from this is that a lot of people have had some really fun build projects lately, putting up TinyGS stations, which I think is really exciting. You get to build something, you get to put something up that you can just leave running all the time, and it will collect data for the scientific community, and I think that's awesome. My challenge to all of those who put up TinyGS stations is to now put up SatNogs stations. Do the same thing, but for a different network. The SatNogs network is targeting different types of satellites. TinyGS is only LoRa. SatNogs is for pretty much anything else. It's a SDR instead of just the LoRa chip for the receiver. And so it can do demodulation on lots of different things. And SatNogs also covers different bands. I think TinyGS can do different bands as well. So if you enjoyed setting up your TinyGS station, I encourage you to set up a SatNog station as well.
Very cool. I saw Randy K7AGE's a couple of his photos of his TinyGS station that he set up, and it was solar powered, and it had like a little egg beater antenna on top.
He's using an eggnogs.
Cool.
Yeah, he's using one of my antennas, so that was exciting. Mine is solar powered as well. So I have a little 5-watt USB-C solar panel that I got from Amazon. They're meant for powering like Ring doorbells or remote cameras or something like that. But it also happens to work really well when plugged into one of those microcontrollers that has a built-in battery charger. So mine is a Heltec LoRa 32 board version 3, and you power it over USB-C, and it has a little LiPo cell hanging off the side. And whenever it's got power from USB, it'll charge the battery, and then when it doesn't, it runs off of the battery. And so the solar power is just there half the day, or actually less than half the day this time of year. But it's enough to keep the battery charged and keep the thing running all night. So there are no wires to my tiny GS station, though it does need to have Wi-Fi coverage to the hotspot in my shop. So that has been on my workbench, or actually it's been up on my shop, which is cool. And then the thing that's actually been on my workbench is I have been making heavy use of my Analog Discovery 2. They're not a sponsor of the show anymore, but boy howdy do I love this piece of test equipment. It is the one that I use more than anything else. Like, I've got a $6,000 O-scope over there on the electronics workbench, but unless I need to do something high speed that it can do that my AD can't, I'll use the Analog Discovery. It's just so much more convenient to have the user interface up on the computer and all the different the tools, like the logic analyzer, which is kind of a digital O-scope, if you will, and the oscilloscope and the ability to output triggers and things like that. It's just been, between having all of that in this one little USB connected device and waveforms, the software that runs it, being able to run all of these tools concurrently and line up all the timelines and be able to view everything all in one place. It's just been an absolute savior for the work that I'm doing with Haliki. So I've talked a bunch about Haliki. If you want to know what's going on with Haliki, go to my blog. Go to electronics.halibut.com/blog. And the most recent post there, as of December 2025 anyway, is about the status of Haliki and why the heck it's been not available for so long and what we're waiting on. And the short version is Andrew Rodlin, KC2G, and I are working on a program called Netgear that it's cross-platform, but it's primarily meant for Windows, that will talk to Haliki or any of the MIDI keyers, including the Linovation CTR2 devices and whatnot. And then it talks directly to a flex radio on the back. So it will do software iambic keying on a Windows machine, which Smart SDR has never done. So Smart SDR could use the earlier versions of Haliki for PTT, but it could not use it for Morse code. You always needed a hardware keyer to be able to do that. So Netgear is going to let Haliki be both a PTT and a software-based keyer. And one of the big problems with software-based keyers in Windows has always been the latency between key down and first tone.
Right.
And sure enough, when Andrew did all of the thing. I just pay the bills for the code signing keys and whatnot. Andrew's doing all the real work. The first time he did it would be like 80 milliseconds of latency between key down and first tone, which is just unusable.
That's brutal. That's brutal. Yeah.
That's brutal. Yeah. And so I hooked up this Analog Discovery 2, where one of the O-scope channels was on the buttons on, the Morse paddles. And so I could see the DC state changing on those. And the other one was on the audio coming out of the computer.
Right.
And so we could see both traces on the screen at the same time and use the X cursors to measure the latency between the two. And building that, we were able to, Andrew was able to get the latency down to about 10 to 15 milliseconds, which is much better, much more gooder.
Right on.
I'm measuring on my computer about 20 to 25 milliseconds, which is not as good as what Andrew is seeing, but it's still a heck of a lot better than 80 milliseconds of what we were seeing in Windows. And it's pretty much on par with what we see coming from Marcus's, the Smart SDR for macOS, which also has a software keyer built into it. So the Netgear application that we're working on is on par performance-wise with SmartSDR for Mac. So we'll be able to bring that same functionality to Windows, which is pretty exciting.
Nice.
And yeah, but that's what's been on my workbench, has been playing with that kind of measurement and all that fun stuff. It's been a lot of fun.
And we think about Bluetooth latencies, and a low latency Bluetooth connection is like 30 milliseconds. And that gets it to the realm of nearly real time, but still 30 milliseconds is how did you phrase it? I said you said usable for CW for sure. It needs to be damn near instantaneous, right? I think people get used to it over time. That's what I hope anyway.
Well, CW doesn't have to be that critical unless you're high-speed QSK.
Well, no, so
and you're running a contest.
Latency between when you're keying and when it transmits doesn't matter all that much. Latency between when you press down the paddle and when you hear the tone.
Bingo.
The side tone
100%.
latency. Yeah,
100%.
and that's the latency that I'm talking
I had
about.
someone visiting the shack here at one point with the QMX, and the QMX has a built-in USB sound card, and I thought, okay, it'll be fun to just turn on the PC audio so they can listen to what's on the air, and then I'll have a QSO, and I started keying it, and I couldn't do a thing because of the latency. The side tone coming from the PC was so different to what I was keying, and I, in panic, thought that the whole firmware version I was working on must be completely broken, but it wasn't. It was just the latency. It's a real killer.
Yeah.
That's why what's his name? Came up with Marconi as well.
Yeah.
So CW remote, as you know, Mark, is really hard to do.
Yes. And it's the latency and the side tone that's really critical. And so that's what we're trying to knock down with the software with Netgear. Andrew, actually it was Rock from Remote Ham Radio, who I'm also chatting with about this sort of thing. He made a spreadsheet of, like, on the left column was words per minute, 5 through 60, and what the precise symbol time is for each of those. And then if you're measuring your key up and down events at millisecond precision, what's the percent error? And like how much latency, and all, so he has all of this data in this spreadsheet. And I think it's 60 words per minute. The symbol length is like 10 or 15 milliseconds. I don't remember the exact numbers. I was trying to find the spreadsheet in my browser history, and I can't find it. But we ended up saying, like, anything above 30 words a minute, I don't think is really going to be feasible in a software keyer. If you're hardcore enough to go above 30 words a minute, you're going to need a hardware keyer with very, very, very low latency feedback. And so we kind of chopped off the 31 through 60 words per minute off of our spreadsheets, and we're not paying attention to that anymore. We're only looking for the, probably the 80% use case of casual CW operation, where we can get our errors down to like 2% error.
Yeah, indeed. When I got my new to me Flex 1500 earlier this year, I had to download Power SDR from KE9NS, and there are some configuration notes that I didn't pay attention to because real ham radio operators don't read manuals.
Yeah.
And so I plugged it in and I started keying. And yeah, no kidding. I plugged it in and started keying. I'm like, what the heck is wrong with this radio? And then I read the release notes on the software. It says, read the release notes, because the release notes contained all of the information about the latency and how to adjust the USB port in my case, because it's an older Flex radio, to remove that latency. And as soon as I did that, it made a world of difference.
Release notes, what a concept.
Release notes, what a concept, yeah.
So I found the spreadsheet. At 30 words a minute, symbol length, a DIT is 40 milliseconds long. And so when we're talking about 20 milliseconds of latency, at 30 words a minute, you're hearing it half a symbol later than when you're signaling it. So, yeah.
On the
Sorry, Mike.
side tone.
Side tone, yes.
Yeah, okay.
Yeah.
Because there's also the other measurement, the turnover time, like a bigger version of the round trip time
Yeah.
from
Yeah.
my brain to switching over to the other mode.
Yeah.
And I have a fair number of people I hear, and they'll hear like 30, they'll hear a number and they think it's huge, but it's not a huge number. And you just can't sometimes get that idea past them.
Yeah. What we need is a visual timeline that shows all the different events and the network traffic and everything else. I'm like, this is the one that your ears hear, and this is the important one. Or if you're trying to do contesting, then this one might be important, but yeah. But
I have an idea. I just got to work out the numbers. So talk for a minute, and then I think you'll like this analogy. I just can't remember what the number is. I need about 20 seconds.
So anyway, I've been working with Andrew on getting Netgear up and available, and that is the last thing. Well, that's not true. I still need to write documentation. But those two things are the last things that are blocking me from selling Halakey MIDI. And for listeners who have not been listening for the last 10 or 15 episodes, I've been talking about this. Halakey is a small dongle you plug into a computer. It's USB on one side and a Morse paddle on the other side. And it allows you to connect to a radio, connect hardware paddles while you're remote from a radio, right? So you're sitting in a hotel with a laptop and you want to work some CW on your Flex radio at home. Or with Marcus's software, it doesn't have to be Flex, right? Because it works on his SDR control for ICOM and his Yaesu and Elecraft, and all of his software packages will work with Halakey. So it's all the radios. And it allows you to plug Morse paddles into the side of your laptop, basically.
So my test mark for you is, if you're 30 feet away and I say hello, how long does it take for the word to get to you in a normal room at 70 degrees Fahrenheit, 50% humidity?
Yeah, STP. Yeah, I don't know what the speed of sound is at STP. What is it?
So it's about 344 meters per second or 1129 feet per second. It'd take just under, 30 milliseconds. You can use the number, it's like 10 like a millisecond per foot.
Yeah.
Is close enough.
Is it really?
Yeah.
Oh, yeah, that's true. Because I know light is about a nanosecond per foot.
Yeah.
Yeah. Okay. So it's about a million times different. Okay.
Yeah. 8.9 milliseconds for 10 feet. Oh, it's close enough to a millisecond per foot.
Yeah. Close enough.
So I had to do that to a guy. I went, okay, if I'm over there, how long does it? And well, it's instantaneous. I said, no, it takes a long time.
Well, very good, Mark. Thanks very much. Thomas, over to you. What's on your workbench?
Well, I don't have a whole lot on the bench proper right now, so this will go pretty quickly. I've been the past few weeks, I've been in a constant state of motion, pretty much. We did have one sad thing in the family. If you read my blog, QRP, you know that we lost our sweet dog Hazel, who was just my little. We called her my brown and white shadow because she followed me around everywhere, and she was just an awesome, awesome, awesome dog, an amazing family member. Yeah. I can talk about that now. It's been a while enough that I can actually talk about it and get it out. But we had,
that's so tough.
It was really tough. It was really tough. But our family, we spent some time together over Thanksgiving, and we're recording the show here early-ish December. The one thing that I try to do, and it's funny because we recorded the holiday shopping show, which Hans, if you haven't had the pleasure of listening to that, it's where we kind of talk about all the things during the year that we, have accumulated and really, that we like, pieces of gear, things that help us out, and we kind of talk about it in one show. One of the things that hit me afterwards, I try to keep a list during the year of things that I'd like to have, but I want to wait for them to go on sale. And so what always happens is it hits right around like the Black Friday, Cyber Monday, all those deals. I wait usually until then to make a decision if I'm going to buy something. And something that I've had on my list for a while is getting another proper modern HT. I've got some. I'm not much of a VHF UHF guy. However, after Hurricane Helene, I realized that they really have a lot of value for MCOM, and also just chatting with people locally when you need to. And I primarily have the Yaesu FT60R, which is a great, really
Oh,
rugged
love the
HT.
FT60.
It's an awesome radio, awesome receiver. When I'm doing summits on the air, I can be near a tower cluster, and that thing does not it doesn't wig out in the presence of all that RF. It's a
Yeah.
solid radio, but I really wanted to have something that could do possibly APRS. And frankly, one of the things in life that I really hate doing is programming HTs or mobile radios. I hate it. I hate doing it. And for that reason, I've always relied on RT system software. I find it works really well. And I can take the same spreadsheet I build for one radio and switch it over to another because we have three other ham radio operators in the family, my wife and my two daughters. And so I usually take the radios and I set up configuring them the same way. So the memories are very similar between the radios. And but I really wanted an HT that could do nearby repeater searches. And so one of the radios I owned in the past was an ID50, I believe it was. It was like the first dual band version of that ID series HT. I owned it ages ago, and it did nearby repeater searches for D star, but I didn't use D star a whole lot. It wouldn't do it for any analog repeaters. But now all of the most recent ID50 series radios, handhelds, they all do nearby repeater searches and include analog repeaters in that. And so that was short on my list. I like it. I've heard so many good things about the radio. The audio is good. It was good in my original 50 that I had ages ago. The battery life's decent. I'm cool with the monochrome display. I didn't really care for a color display necessarily because the battery life was great. But it did lack APRS, and that is something I like having in an HT if possible. And I sold the only HT I had with that, which was my FT2DR, which I'd known for years and years and years. And the so anyway, I was trying to decide between the ID50A and the Kenwood THD75
And you got both.
because that's what we do on
That's
the
because
Radio
that's what we do
Workbench.
in Workbench. That's right.
I couldn't help it. I was looking at them and they were both went on sale during the Black Friday thing, and I got the ID50A first. And I got that one day from DX Engineering, and I thought, I'm just going to go ahead and get the D75 too. And and so I did. And I've got both of those sitting here now. And the cool thing about the D75 is it does APRS, and it does it really well. I have another Kenwood. Actually, I do have another Kenwood HT with APRS. I just don't think about using it for that because it's more for satellite work, and that's my D72.
Oh yeah.
They all kind of work similarly. In fact, Kenwood, I was really surprised how similar the menus operate between that D72 and the D75. There are quite a few similarities navigating them, and I do find Kenwood radios very easy to program from the number pad. They're one of the easier ones I've had besides the FT60R, which Yaesu seemed to have done that for one radio, and then they're like, no, that's too easy. We got to change it up for all the rest of the radios, and so they'd make any other easy to program from the front faceplate sort of thing. And so I've been exploring these and learning how to use them, and it's a bit of a deep dive. They both have learning curves for being pretty intuitive. They do have learning curves for programming and learning the nuances of setting up everything. And I haven't even touched base with any D-Star stuff with it. I may play with it a little bit. I have done D-Star in the past, but now though I'm kind of looking at it thinking, the FT5DR is also on sale, and why not just get the third one of those same HTs? Everybody's always deciding between those same HTs. Why not get that one and then just compare the whole thing, and then probably give one to one of my daughters or something?
Well, then you can follow the GMN4JAW naming convention. Bada bing, bada boom, and bada bam.
That's right. I could do that. I could just collect the set, and so I like that. Yeah, Vince has named he's named his QMXs bada
Bada
boom,
bing
bada
and
bing,
bada bing.
bada
Yeah.
boom.
After Jim did that, and then he says, "Yeah, and now I need to name one bada bam or something else."
You should
Anyway,
name the radios you plan to keep.
yes.
That is my policy.
Yeah.
And so yeah. Anyway, so that's stuff I'm learning. I'm trying to get into. I need to make a decision about the FT50R if I'm going to do that, because a lot of these things still are on sale, I think, through the end of this month. Um, the other thing is that we finally had arborists come by, and I think I mentioned in the previous show I was on, which was probably 2 shows ago, that we were having arborists come in and take down the trees that were really problematic after Hurricane Helene, the ones that were above my pay grade to drop. And they came in, and in fact, because of a little scheduling conflict they had with a couple of the helpers, they were only able to work half a day. But that half a day, they worked behind the house, which is the place that I've been waiting to be cleared out, so I'd know where and how I can put up antennas to replace the ones that came down in the storm. And I'm not planning to put up towers or anything like that. These will all be wire antennas, but I do now understand what I can do. And I'm probably going to be combining my antennas with a receive wideband amplified loop antenna as well, to kind of mitigate some of the noise during the day that's produced by my PV system on the house. And so I'll probably use like a separate receive antenna. I may try some beverages on ground and some things like that as well. I've got plenty of room to do that. I'll probably put up like a 40-meter delta loop. I may put up another horizontal delta loop like I did in the past. I'll need to have an antenna party for that one. And probably I may put up a doublet or a dipole. I'm not sure, but I'm going to measure it all out and see. We have still some really, really tall trees that I could hang some verticals from as well, which is really nice. So I'm trying to plot all that out. The only other thing is it's getting close to the end of the year at the time that we're recording this. And by the time this comes out, it'll be very close to the end of the year. But I'm trying to figure out the SOTA summits I can hit yet before things get really wacky. A lot of the summits I like to activate are now closed off because they closed off the Blue Ridge Parkway, which really provides access to probably 4 different summits I like to hit. One of them I did get earlier this year, Mount Mitchell, but now I'm looking at all the other summits that I can gain access to, just, that have their own, their own public roads, like the trailheads on a public road or something, and try to fit those in and get my extra winter points. I can get winter points up until I think sometime before spring starts. But I do want to get back into the SOTA swing of things because I've been missing activating summits, which is like actually one of my favorite things to do in the field.
Oh,
That's
very good.
that's pretty much all that's going on my way. I don't really have anything on the workbench proper.
Nothing much. I mean, get that FT5DR. I had one. It's a wonderful radio, and um, I would love to keep all of the radios I've ever had in my life. I don't have the space, and more importantly, I don't have the bank account to do that. The 5DR was a very lovely radio. I landed up selling it off, and I bought a THD 75 because I really did want to experiment with the full KISS TNC, which
Yeah.
I've not done yet. But
Yeah, that's on my list too. I want to play with that. And also, the one really cool thing about the D75 and a lot of Kenwood HTs is they have really wideband receive. Like, so
yes,
they go down into like the medium wave band. And it's true that you're not going to get like crazy performance out of that, but it is awfully nice when you've got an HT. Like I was using it the other day, and it has a little mini ferrite bar inside that HT for medium wave. And I think it engages all the way up to 10 megahertz. I don't know what you'd be able to hear much on the HF bands with that. But it also has multiple modes. It does USB and LSB, so you can hear upper sideband, lower sideband. But I can actually pull up some of we actually have a couple of kind of cool medium wave stations, and you can actually record the audio to an SD card, I believe, from those. So it's just kind of a neat. People don't think about some of those functions. I have always been a receiver guy too, so
right,
it's fun having that and trying to optimize it and make it work. It's not going to be as good as a dedicated medium wave radio or a dedicated shortwave radio for listening to shortwave broadcast or anything, but it's great in a pinch.
right. Yeah,
Can,
very
can
good.
I add a little bit to the HT discussion?
Yeah,
Yes.
please.
So I got an email on the morning of December 5th, which is 2 days ago as of the day we're recording this, from anytone.us,
Mm-hmm.
ed at wushan.us. And it is announcing the AT D890UV. So the next Anytone radio, the 890, which is the successor to the 868 and the 878. And one of the key features that was listed in the 890 is true, proper crossband repeat,
Wow.
which means full duplex operation. Transmit on one band, receive on the other band, which is what's needed for satellite operation.
Oh, yeah.
Does it say it's full duplex in band? Because
No.
I've seen full duplex crossband.
Yeah, no, you don't. No, it will not do full duplex in band. There's no way to do that without duplexers.
Okay,
So it's crossband.
full duplex
See,
crossband.
like,
Okay,
But that's what you need for satellites because the
70
uplink is on
centimeters, 2
2 and down
meters.
on 4
Yeah.
or vice
Yep.
versa
yeah, okay.
on 440.
Yeah, there was some speculation about whether this was a radio that could act as a built-in repeater.
So
my old Kenwood TM732 will do
I
in-band
was-
repeat.
They don't still make those
example.
anymore. Like the old ICOM W2A, which I know I own one somewhere, was great.
Yeah.
I worked a lot of satellites with that.
Yeah.
Yeah.
That's crossband repeat. The only way to do in-band repeat
With
for
full
FM
duplex.
is with duplexers.
Of course. Yeah.
I think it can do time slot repeat on DMR, receive on time slot 1, transmit on time slot 2. I think I saw something about that maybe, or that might also be crossband, but it can do some DMR repeat stuff as well.
It is absolutely amazing how much functionality can be stuffed into a little tiny box that you can hold in the palm of your hand, isn't it?
Yep.
Something the
Yeah.
size of a
I wonder
credit
who
card.
could do that.
Yeah.
Yeah, I know.
Anyway,
I know. I wonder who here on the show can make really tiny radios.
Incredibly small stuff.
Now, I will say this. And I think this is one of the things that kind of blows my mind. It really surprises me because if I could take probably 5 of my favorite HTs throughout history, right? Like even some legacy ones and some modern ones, and smash them all together and make an HT that would just be killer. Like it'd have all the things I want on it. It would have DMR, it would have APRS, it would have at least, it'd be at least dual band, and it would have like GPS built in for APRS, but also for nearby repeater search with memory banks that you can load up on an micro SD card and that would be USB-C natively rechargeable, right? All of those things exist in a whole bunch of HTs, and the ability that when you're traveling with an HT or a mobile VHF UHF radio, that it moves your repeater search along with your footprint as you go down the road, right? I've always thought that they should be able to do that, But like none of these things really exist in one unit. In fact, I don't know of any that change the footprint as you're moving along that does it natively inside the box.
This is where we need George. Isn't that where Garrett is sort of trying to get to?
I'm not sure.
Which is this
Repeater
product,
book?
one of the repeater directory products.
Yeah, repeater book.
Oh, repeater book.
Yeah.
Yeah, I understand, and I haven't tried this, but you can Bluetooth connect to at least to the D75, but maybe to other radios as well, and it will do something similar to that, where your mobile phone basically sends the data to your HT and programs it along the way, changing your footprint. I just think it'd be really cool, and I'm going to try that if I can figure out how to do it. I actually have to get a separate dongle for iOS because that uses a different form of Bluetooth than the TH D75 does. But
So I'd be remiss if I didn't point out that the KV4P HT software does that. It will connect to a repeater book, and I don't know if it'll do live updating as you're driving across country, but I do know that the software plugs into repeater book running on the same phone and will automatically program and make available, what local repeaters are there available inside the software.
and what was the call sign again for that?
KV4P. That's the little HT board that you slap
right.
to the back of an Android phone.
Yes. Okay, gotcha.
The one where I did the hardware design for that.
Yes, that's right. Okay, I had not thought about
I
that.
have one
That's
on my
really,
workbench right now. This little guy.
that is really cool.
Right on.
Well, I tell you what, I've talked enough. Vince, what's on your workbench?
I thought you would never ask. Thank you so much. Well, oddly enough, I have 2 QMX radios, and I had to label them because I can't tell them apart physically. So taking a page from Jim's book, I have named them Bada Bing and Bada Boom. And Bada Boom is the low band version of it because, as any music nerd knows, drums emit low notes most of the time. And, well, that's how this music nerd can kind of keep his arm wrapped around him. I'm especially excited to have these radios in my possession because they will help me compete in Adam Kimmerly's 454 gram, or as he calls it, the 1 pound challenge. And so I'll be able to build some really tiny kit to go around it. I don't know if I'm going to, actually build the choking hazard transceiver or purchase one. I think these will be just fine, but part of my reason for wanting to do that, of course, is now that I've got that Trek e-mountain bike, is to go off in backcountry and explore other areas, and I really want to lighten my payload. You heard me last time talk about selling my KX3 and getting a KX2. These QMXs came in at around the same time, helping me towards those goals. So I am a good ham radio operator. I did open up the 132-page manual for these firmware versions of the QMX, and I have been making my way through them to configure them so that they operate exactly the same. So I don't have to think about it. Like, I don't want the CW decoder turned on, so I turned that feature off, and other similar things. When they power up, I want them to show. I programmed message 12 in them so that they powered up with a message that gives me something useful. In this case, it turns on and says bada bing or bada boom,
yeah.
Just because a guy can. So anyway, I'm loving these things. Hey, I got together with my friend, ham radio rookie Ben V6SFX. You may know him as the guy from VF Comms. I've been talking about him a lot recently because he has released his new rugged signal element line wire, if you will, for people to build antennas, and he sold out in a day. Now, on the day that he set it out to market, I went up and I recorded some videos with him. I was trying to do the videos myself at home on how to solder and how to crimp, and, trying to be a one-guy production house with 3 or 4 cameras going, and one of them falls out of focus and you don't know because your hand's on the soldering iron. Well, that just proved, frankly, to be a recipe for frustration and my return to consuming alcohol. And so I didn't want to do that. Potty Mouth did make some appearances. Anyway, I went up and I hung out with Ben for about an hour, and we shot a bunch of footage. And those videos have just released. So if you go to my YouTube channel, you will see some really good, detailed how to solder, how to crimp, and some other tips about this RSE line. And
give us a summary of what the RSE line is.
The RSE line, thank you, Mark, is a carbon fiber core, and every strand is individually coated with nickel. And then it has a polyester braided outer jacket on it. When I was talking to him yesterday, he said, yeah, it probably wouldn't be too hard to make that polyester jacket slippery, like throw line. Oh, well, that becomes very interesting. Combination of throw line and antenna wire all in one.
I'd love to know about that. Yep.
Believe me, I would love to know about that too. So
also using the antenna wire as your guy lines for a mast as well.
Exactly, and all of those things. So I've been experimenting with it. I haven't had nearly as much time in the field with it as I want to. Winter has set in here, and with 8 inches of snow on the ground and minus 15 Celsius kind of temperatures, it gets a little depressing to want to think about to go and operate outside. But I'm waiting for a sunny day to go off and do that.
You're talking weather that like Mark really can't even comprehend. Like he's
No.
like it's like you're just saying blah 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 because I mean, first of all, snow, -15.
Yeah, well,
It's the same
exactly.
for me. We don't get
I'm like,
that here either. Our
You don't.
daytimes are about plus
yeah.
20 centigrade these days, and
Ooh.
we never get snow here.
Well, and so all this weather and so the other thing I've discovered, and you've heard the story of I was trying to get my third soda attempt in with my then new to me bike this year, and I somehow sprained my knee. Well, I've discovered I'm not 29 anymore, and it's taken an awful damn long time for my knee to heal up.
Mm.
And I have considered, getting studded tires for the bike and maybe trying to take it out in the winter to at least to promote some healing. I don't know if I'm going to get to that or not, but I'm so close to being back to normal, but it has taken an awful long time.
What you
Uh,
need is a good stationary
oh,
bike at home that you can practice on when you're
it,
when
it,
it's weather like that.
Yeah, I need the room to set up a stationary bike because my entire basement shop is absolutely just jammed, and I have to find a spot to set up a stationary bike. I've got two
Mine's right
bikes
here.
now, and one's in the garage, and I could bring it down from the ceiling and pop it up on some rollers, I'm sure, but it being an e-bike, I might just be tempted to turn the throttle. I might have to remove the battery from it. Anyway. So along with that 1 pound kit that I'm building up, I am currently in the midst of building up some K6ARK and fed half waves.
Hmm.
These are in the form of a little tiny BNC connector and a small toroid and some frustrating magnet wire.
Yep.
And did I ever mention that the reason that I love buying assembled QRP Labs products is because I don't have to, or Alacraft product for that matter, is I don't have to wind the toroids.
Ah,
Oh,
ah,
yeah.
toroids aren't that bad.
Oh, yeah. Well, dude,
You're
so,
perpetuating the myth that toroids are difficult
well,
and
toroids
making
are not
everyone
difficult.
scared of doing
I'm
their
Okay,
with
own
Mark
look,
on this
homebrew.
one.
look,
Vince,
toroids,
look,
toroids are not difficult.
this is the QMX Plus, and
Yes,
you can see that in here there are 12,
50.
13, 14, 15, 16, 18, 19 toroids and some vernacular transformers. And one of the things I forgot to mention about what I did do this week, I built one of these, and it's probably only about the third QMX Plus I've built. But I wanted to get a measure so that we can evaluate productivity in the office where they're building hundreds
Right,
of these per month, right?
right.
And so I wanted to build it myself to get an idea. And I wound all of those toroids and everything and built the entire QMX Plus and had it working in 2 hours, 20 minutes total.
Wow.
It's not
Well,
that hard.
And
well,
an hour and 45 of that was T1.
That was on the QCX T1.
Oh,
You were
yeah.
talking about the QCX. T1 was famous on the QCX because it had four
I will
windings.
admit that one was a challenge, but
And
just
it
standard
was yeah,
inductor toroids is no big deal.
right, right.
and
It's
and
just patience.
it's patience. And so last night I was sitting at the bench, and for those of you watching this on video, you can see that my bench, I'll move aside here, is not its normal tidy self because I'm building a 49-1 and a 9-1 version of the K6ARK. And I'm going to mate it to the RSE line because that's what I want to do. So I wound the 49-1 without issue, and it was the 9-1 that absolutely stymied me. And twice I wound it and wound it wrong because I didn't read the instructions.
Back to the release note problem again.
No, 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 no. The instructions were, Mike, the instructions were on screen in front of me.
I
But
know.
I missed the part where he said, and after you've wound it a second time, go around one more time. And I missed
Ah,
it,
I know.
and I missed it twice.
so they don't have you wrapping 3 at a time?
No,
Okay, yeah.
no.
The
So
typical way
you,
of doing
you're
a 9-1 is you get 3 wires
yeah.
that you wrap at once, and then you do some chicanery with joining one to the other. I personally like the once you go around once, go around another time section solution better. That way you're not having to like solder right next to the ferrite. Yeah.
He
Yeah.
needs the. Here's what we're going to tell you. Now we're going to tell you, and this is what we're going to told you part.
Yeah. Yeah.
Yeah. I
Like
should
a
have.
typical teacher.
So like a typical
Sorry,
YouTube.
Vince.
Yeah, thanks, Mike. I love you too, brother. So the what I learned was I could stand to read the build notes once completely, and then read them a second time as I'm starting the build, which is exactly what I hope that my customers do when they buy kits from me. And what I should have done in the first place. But I took a look at this thing and I went, oh, this is so simple. I'm just going to hit it. And that was the biggest dumbass
How'd that
thing I
work out
did
for
this
you?
I
week.
have
Yeah, it
no
didn't work
idea
out at all.
how I blew up that audio amplifier on your equipment, on your stuff.
It's been known to happen.
Is it a line in there about turn this pot down first before powering up or something?
Yeah, I don't remember. Those are Bruce's instructions after all, not mine. But hey, listen, that's what's on my workbench. We're going to take a break and we'll let George do whatever he does during the break segment, and we'll be right back. Stay tuned. Well, Hans, we're absolutely tickled pink that you're here with us today. And I thank you so much for your time because I can't begin to imagine how busy you are. I'd like you to take us back, if you would, please, to tell us about your sources of inspiration for building rigs. Tell us a little bit about the history and sort of bring us forward to where you are today with QRP Labs.
Sorry, go on.
Well, there was a guy called Pat Hawker, and there was a guy called Pat Hawker, G0UPL, who used to write a monthly column in the RSGB journal Radcom called Tech Topics. And pretty much, people would sometimes criticize the content of Radcom because they can't please everybody. They try to balance the articles and the content, but there was always something in Tech Topics that I found interesting, and he was generally reporting on different technical developments from around the world. And he reported on Dan Taylor's quadrature sampling detector. It's where I got the original idea for my one tube transmitter that I had my first QSO in 2002. And so many ideas and inspirations that I had came from that column. So he was a really major inspiration. And then, so I had started documenting some of my projects on my website, and at the time, I mean, I spent 22 years working in IT, in investment banking and hedge funds, doing application and software development for derivatives pricing. And so there was often not all that much time to do radio-related things, but when I did, I was doing projects and homebrewing. That was always my thing. And around 2004, 2005, I got into this very weak signal stuff where you transmit very, very slow CW, where, you're talking earlier about latencies and DIT lengths and things like that. But in very slow CW, you choose DIT lengths of 3 seconds or 5 seconds. We're not talking milliseconds anymore. We're talking 5-second, 10-second DIT lengths. And what that does is when you use a Fourier transform software like Argo or Spectrum Lab or some of these audio software, you get a very, very low bandwidth, which produces a really high signal to noise ratio. So with milliwatts, you can be copied on the other side of the world. And so I got very interested in this. And then I was invited in 2009, as you mentioned in your introduction, to be inducted into the QRP Archie Hall of Fame. And the following year, 2010, they invited me back to speak on this topic of QRSS. And I presented, my whole sort of history in QRSS and how I'd played with these various experiments. At one point, I had a tiny transmitter that was producing about 2 or 3 milliwatts and powered by homemade batteries. And I built these batteries in a food can filled with bleach, and then a copper wire house wiring that was wound around a empty orange bottle. And so those were my 2 electrodes. And I had 4 of these in series, and it produced 2 or 3 volts of battery power to power this transmitter for about a week. And it produced a terrible, terrible smell and a huge mess. The bean cans eventually dissolved, and all the bleach was going everywhere, and corroded metal, and it was standing on some saucers from the kitchen that never ever became clean ever again. So I was in quite some trouble for that. And
Oops.
so there was all these nice stories that went through, and we were talking about QRSS. And one of the things was in the summer about a year earlier, so it would have been about 2009, I'd been on a 2-week vacation to Grenada in the Caribbean. And 2 hours before we left for the airport, I decided I should take a transmitter with me and do some amateur radio there. So I built in 2 hours this very weak signal transmitter. And it was somewhat not as hard as it sounds, because I already had the low pass filter scrap somewhere on a module on a bit of board, and a keyer that would do the modulation. And so that all worked great. And I was getting reports from around the world with this 100 milliwatt transmitter. But then when I gave my talk at Dayton, my friend Steve, Golf Zero X-Ray Alpha Romeo, suggested to me, well, why don't you make a kit to go with the talk? So I decided to make this board into a kit to go with the Dayton talk and sell it. And we sold it for $15, which was, everyone thought that was a steal to have a bit of fun like that. And the microcontroller which generated the modulation was individually programmed with the call sign. And that evening at Dayton FDIM vendor evening, all the 100 kits I'd prepared sold out in the whole evening. They were completely
Not
sold
at
out.
all surprised.
And
Yeah.
we went back to UK, and we continued manufacturing these kits and selling them online. And it went on like that. And then I developed the ultimate transmitter. It was called the Ultimate Whisper QRSS Beacon, and it was the first standalone whisper beacon. So it could transmit whisper without using a PC to generate the modulation. It was all done on the microcontroller. And from there, the kits kind of evolved, but it was still very much a kind of just a part-time hobby thing. It wasn't really something that I took seriously. And then Steve, in late 2012, he had a lot of other issues, personal issues, and found that it was getting stressful trying to ship out all these kits. He was doing the shipping and packing, and I was doing the software and documentation and technical side. And so he decided, we should close this down, and so we did. And in around March, April 2013, I decided to start it again on my own and made the second generation of ultimate transmitter beacon kits. And from there, that was really what I think of as the real sort of starting date of QRP Labs, because that's where I really started taking it seriously. And I was still working in a bank. So at that time, I was working in a bank in Japan, and we lived in Japan from 2011 till 2016. And I had a bedroom closet. I like this story. We had a bedroom closet in our apartment, and it was a 5 by 4 feet walk-in wardrobe. And that was where I had a tiny little IKEA desk and chair, and I had my oscilloscope and later a spectrum analyzer and all my racks of components. And I would go in there, and I would sit in there and close the door and do my development.
There was room to close the door. I'm impressed.
The door opened outwards, so that was why there was room.
I was gonna say he's got you beat, Thomas.
Actually, I just did a quick measurement of my office, and it's about that same size. It
Well,
really is. It's 8 foot by about 5 foot. And
Maybe
that's my
That's
whole
exactly
office.
twice the size of my walk-in wardrobe.
And,
Mine was 5 feet by 4 feet.
okay, got you. Well, I will say this, in the house, while I was building my house, I just kind of had to carve this little room into it. We also made a very small bathroom to what can be converted into a guest room. And while I was building the house, one of my Japanese friends would come by and visit every so often and help me with a few things. And I remember telling him, like, yeah, I think the bathroom may be a little too small. And he went in and he's like, this thing's huge. And
I
I
know.
was like, yeah, probably to him it is. But
I mean,
that's great.
our apartment in Tokyo was 70 square meters, and every Japanese person who came in, they said, "Wow, what a huge apartment!" They were to them it was really big. A friend of ours, she had what was a more typical apartment size. It was a 19 square meter for the entire apartment. So, the bathroom fits in that, the kitchen along one wall of the room, and yeah, in Tokyo, small sizes are the way the buildings are done. Anyway, so from 2013 until 2016, 3 years, this was all just an evening weekends activity. And my daughter was born in 2013. She used to wake up at 6 in the morning, and I'd sit there on the floor of the room packing kits up and labeling boxes by hand, and then I'd take them in a bag to work. And at lunchtime, I'd go to the post office and send them out. But the kits turned out to be so popular, and business was growing so well, and eventually I was very, very tired after 22 years of that business. It's quite a, working in investment banking and money industry is quite a sort of cutthroat business. And there's a lot of waste and corruption, inefficiency. And I was very, very tired of it by that stage, and managed to convince my wife to let me do this radio thing full time. And so we moved to Turkey. She was very worried about the whole financial situation. And at that time, the cost of living in Turkey was a lot lower than it was in Tokyo, in Japan, or in London, for example. Now it's pretty much the same. We've had several years of quite high inflation, and so the cost of living has really gone up here. But at that time, it was a lower cost of living, and we had somewhere to live here. We didn't have to pay any rent and everything. So that was why we moved to Turkey. And she also set me a 2-year deadline, so I had to make money within 2 years. Otherwise, we were going back to London to get a proper job again. And so that was all. That was how we moved to Japan. And then the first real breakthrough, or the big breakthrough, as I call it, was the QCX transceiver. And I'm sure that you're familiar with this. It was a single band transceiver that was covered CW only.
I've only had like 3 of
5
them.
watt.
Yeah.
And you say
That's
QCX, and you don't mean the mini.
Oh, right.
You
Well,
mean
the
the
QCX Mini came
aluminium box,
later.
like 6 by
That's right.
4
QCX
inches.
was
Or,
first.
Yeah, the
yeah.
original QCX was a 4 by 3 inches PCB, and it actually originally came about because of the RSGB, and they had sent me an email, and I believe several other kit producers, asking for suggestions for the YOTA 2017 Buildathon. So they were hosting this summer camp for youngsters in UK that year, and they were looking for suggestions for a Buildathon to hold on one of the days. And they had £1,000 budget, and I translated that to dollars at that time, and per attendee it came to $16 per attendee, 1/6. And I just laughed. I thought, what can you do for $16? I laughed and I deleted the email. I thought, you can't do anything for that. You might be able to make an NFED Torrid match or something, but nothing too serious. But then I couldn't get my mind off this, and I'd wanted to do a transceiver for a while. And I had, by that time, in my product range, all the modules you'd need to make a transceiver. I had a receiver module, I have a 5-watt power amplifier module. But the problem was, because they were all modules, when you put them all together and you bought them all separately and you manufacture them separately, the cost was quite high. But then I started thinking, if I integrated everything onto one board that was purpose designed as a CW transceiver, and if I made 500 kits and I sold them for such and such, and I subsidized to the RSGB, then I could make this work. And so within a few hours, I'd actually written my proposal. I'd undeleted the email and written my proposal to RSGB. And that night, I literally lay in bed with my eyes open, designing this thing in my head. And I couldn't sleep. I just lay there all night, just staring at the ceiling. And it was a Friday night, I remember. I was itching all weekend because I couldn't get started on it. And Monday, I started building. And a week later, I had my first QSO. It was an Italian station. I remember it very well. And then it took a couple of months for the RSGB to have committee meetings or whatever and make a final decision. So it wasn't until May, when I got back from Dayton, that I really started trying to finish the project off and have it ready for 5th of August or whatever it was when they were having the actual summer camp. And so the QCX turned out to be tremendously popular, and the other 410 of the 500 I made, which didn't go to RSGB, they sold out in 28 hours as soon as I put them online on the shop. And so we were very, very soon deluged with orders. It was really, really hard to keep up. And to date, we've sold, I think, almost 22,000 of the QCX series.
Holy
So
cats.
it went originally from the QCX, which was just the board, and a German company made a sort of bent aluminium enclosure
Hmm.
for it and started selling
Hmm.
that.
I have two of
And then
those.
in 2020, I decided to change it to QCX Plus, which was a larger board, easier to make, more space for modifications. And we've got quite a few addicts on this call, I can
Oh
see.
yeah, you're among friends here.
Yes, you
And
are.
so
You're among you're a lot of
You're
your
among
customers are in this
fans
room.
here.
and so QCX Plus was a larger enclosure, more space for modifications, but it also was the first time that I was then producing the enclosure as well as the transceiver to go inside it, and they were designed to fit together very perfectly. And it fixed one of my original complaints with myself for the QCX was it was a poor mechanical design. You
Hmm.
had connectors coming out the left and the right, and all the encoders and the encoder and the volume and the buttons were all at different heights, different height to
Hmm.
the
Hmm.
LCD, and it didn't easily. It was a very nice transceiver with very high performance for its cost. I think it was $49 that they originally went on sale for, but it wasn't easy to put that in an enclosure. So QCX Plus was really designed to fit in an enclosure. And then some people said, oh, it's too big because it's bigger than the QCX. And the QCX was a better form factor for portable operations because it had the controls and display on the top rather than a conventional sort of desk mounted front panel arrangement. And can we make the QCX as well? And I didn't really like going backwards, so I decided I'll make them something really small, which turned out to be the QCX Mini. And so that's what you're talking about just now. And so that was around late 2020 that was ready. And then I continued and I did this digital transceiver, the QDX, which
Hmm.
is a little bit smaller than the QCX Mini. And I'd actually designed QDX around the beginning of 2020 and had it working as a prototype. And that had got interrupted, the work on that had got interrupted by my smallest child, who was born in June 2020. And that kind of family upheaval,
Yeah.
and I finished, sort of suspended the development of that at that point. So it wasn't until October 2021 that the QDX finally went on sale.
So,
And
can I ask you to tell me if you want to hold off on this distinction, but I would love for you to describe the distinction between the QCX, the QDX, and the QMX from an
yeah,
architectural standpoint. Would you like to do that later, or you want to do that in the timeline?
uh, well, let me come to the QMX in the timeline, and then it will be
Okay.
a good point to do that. So
Okay.
QDX was just a digital transceiver, but it uses all embedded SDR. It's very similar architecture to a Elecraft KX2, KX3, where it does a down conversion to a baseband and then a low intermediate frequency, all in DSP. But QDX was only digital, so it had a built-in USB sound card and virtual COM serial port for CAT. So it interfaced very perfectly with something like WSJTX, and everyone who wants to use FT8, it just interfaces perfectly with that. And a couple of years later, then, so it was May 2023, I developed QMX, and the M was for the marriage between Q6 Mini and QDX.
QDX.
So it looks like a Q6 Mini. It looks
Oh,
exactly like a Q6 Mini.
I never knew
But
that's
the
what
M
the
was
M was
also
for. I never knew that.
no, the M was for many things. I joked about this in my presentation at Jason. The M was for magnificent, marvelous, marriage, multi-mode, multi-band. It was for all of these things because QMX was 5 bands and but multi-mode, so CW and digital, and with the promise of SSB coming later.
Right.
And so that was QMX, and QMX is a really major transceiver because it's perfect for SOTA operations, POTA operations, portable stuff, with the multiple modes, the built-in sound card for digital operation, and now SSB as well. But to come back to the architectural differences between the two, so in QCX stood for QRP Labs CW transceiver. The X was for transceiver. QDX, the D was for digital, and M in QMX was for multi-mode or marriage or merger or all these M's that you could have. And so, but QDX and QMX are very similar architecturally because they're both or the receivers at least, because they're both a down conversion stage to a low frequency sampling, and then everything else is done in DSP after that. Whereas QCX was an entirely analog transceiver, which used an Atmega 328 to control the synthesizer, the 5351 chip user synthesizer, but also to do CW decoding, side tone generation, iambic keying, VFO-A, VFO-B, message memories, frequency memories. All of that was done by the microcontroller, but it was still a completely analog signal path. Whereas QDX and QMX, and probably every other radio I will ever design in future, is an entirely digital DSP transceiver. DSP transceivers have higher performance per cost and the opportunity to make firmware upgrades to deliver more functionality later, which is what happened with QMX because the SSB firmware was added to add a whole new mode to it. And so architecturally, QMX is most like QDX, but it looks exactly like QCX Mini. And then a year later, I made QMX Plus, which is a larger version still, and looks and in the same case as the original QCX Plus. So I was kind of reusing these mechanical concepts as well as reusing firmware concepts, reusing circuit blocks in the schematic. So in QMX Plus, the original CW Kia comes all the way back from my first QRSS kit in 2009. 2010. The same code is being reused as things go, and I see the blocks design, the circuits and the project's design ways as kind of like Lego blocks. You're putting together different software components and hardware components and mechanical components that I've done before, and then adding a few new ones to generate the new functionality. Of course, QMX also has transmit of voice, whereas QDX was just digital. So QDX being digital, it measured the audio coming from the PC from a software like WSJTX, and then commanded the synthesizer as a single carrier to that exact transmission frequency. So it wasn't a sideband transmitter as such, it was just a carrier transmitter whose carrier was being modulated to match the digital modulation coming from the PC over the USB sound card.
And
Whereas
consequently,
QMX is a...
consequently, the QDX is a constant carrier, correct?
Yes, absolutely.
Yeah,
So it's a constant carrier. You can't do modes which have carrier amplitude modulation or phase modulation, which is effectively also amplitude modulation is required.
Yeah.
You can only do FSK digital modes. So
So
things like
that's things
FT8,
like,
JS8, Whisper,
but
RTTY,
not
all of these.
BPSK or
Right.
sideband. Yeah.
Right. So
Yeah.
things like VARA, things like PSK31, they require phase shift keying or have multiple tones. You couldn't do those on a QDX.
Yeah.
Whereas with QMX, the transmit architecture was different because I also added this amplitude modulator. So actually QDX and QMX, the transmit side is almost the same and the receive side is almost the same. But QDX had no user interface. It was just a USB connection to a PC, whereas QMX has the display, buttons, rotary encoders, and of course the earphone output for audio that you get on the QCX, the original analog CW transceiver. So QMX is very, very similar. The only addition really is the amplitude modulator, which lets you do single sideband via polar modulation. So I don't know if this, I've said the word polar modulation. I don't know if this is a good moment to describe
When you're
roughly.
a flux, you're a flux.
We had Tony K1KP. He was here a handful of episodes back, and I could use a summary of polar modulation, but explain like I'm 5.
Well, I
second that.
first met Tony. I first met Tony K1KP at Hamvention in 2019, and at that time we had these ClearSpan tents in the Dayton Hamvention. It was at the current arena, the Green County Fairground Arena, the current location. But there were these ClearSpan tents, and the QRP Labs booth was in one of those ClearSpan tents. And Tony had a desk, 3 or 4 desks along me on the same row, where he was showing off his Polar Explorer polar modulation SSB transmitter, and little known to me, that was actually where Flex Radio saw his transmitter and quickly started making contracts for him to sign and things. And then they went into their development phase, which ended up with Aurora. I hope I'm getting this right, Mike.
Yeah, that's pretty close. Tony tried to sell the idea to everybody. And
Right.
Steve N5AC, who you met, got it right away.
Right. Yeah. And so, so that's when I first met Tony. Then I didn't really, so I was kind of aware of this polar modulation, but then there was this guy, Guido, PE1NNZ, who developed a special firmware version for QCX, where he implemented polar modulation on a QCX, which was heavily modified, and made it into a multi-band sideband transceiver. And you remember QCX was just an all analog CW transceiver. And for him to have done all of that DSP in a very low-powered Atmega 328 processor was an incredible job. But it kind of showed what was possible to do, even with very limited hardware. So
He
the
put
idea
polar
with polar,
modulation in an 18 mega?
yes, he did. Yeah.
Holy,
Yeah.
wow. Okay.
Yeah.
I was impressed that you were able to fit all of the QCX code in the 18 mega 328.
Yes.
Okay.
Yes.
I'm
The
flabbergasted.
the QCX code in the Atmega 328. So the Atmega 328 has only 32 kilobytes of program memory, flash memory for program. And in the QCX, I use exactly 32,768 bytes of the 32 kilobytes. And so there is not one byte spare. And I kept getting more and more requests. I got requests for cat control, and the original QCX had no cat interface,
Yeah.
and that was all added later. And I had to keep finding ways to make the code more efficient and squeeze it so I could put in this extra functionality. And so, but I think the biggest thing that Guido did was not just with the code space, the 32K of code space, but also the limited CPU speed, the limited
Yeah.
resolution of the ADC that he used as a 10-bit ADC. It was just incredible. So when it came to QMX, I kind of thought I will put together. My original idea with QMX was I was going to combine the CW transceiver of QCX with the digital transceiver of QDX. But when I saw what Guido had done with USDX, as it's known, micro SDX, which does all of this polar modulation SSB with a 328 chip, this Atmega 328, I thought I could also incorporate that in QMX as well and make it truly multi-mode, so it covers SSB, digital, CW.
Wait.
No,
The true SDX, the little plastic box, has polar modulation in it?
yes,
I did not
yes, it
know
does.
that.
Yeah.
Okay.
So what the way this works is very simply, you take the speech the audio, and you divide it up into a phase component and an amplitude component. And you then modulate these separately at the output of the transmitter. And the advantage of this is that the power amplifier doesn't have to be linear. So in a normal SSB transmitter, you take the audio and you mix it up to the RF, and then you put it through a filter, for example, a crystal filter, and you chop out the unwanted sideband and you chop out the residual carrier. So when you modulate, you essentially have AM, which contains a central carrier and two sidebands, and use a filter to chop out one of those sidebands, and then you amplify the result using a linear amplifier. But linear amplifiers are very difficult to make high performance, and they're also very inefficient. So typical Class AB linear amplifier may be around 40% efficient at most. So it generates a lot of heat, and it's very difficult to get this straight line response between the input signal and the output source signal. You want linearity, otherwise you get distortion. The advantage of polar modulation is that you're no longer doing a linear amplification because you've separated out the amplitude and the phase modulation. You can do the RF amplification without needing to have a linear. So it's kind of like, the way I think of it is, imagine you're in New York City and you're a human and you want to go from 35th Street, 3rd Avenue to 48th Street, 5th Avenue. You know that you're going to go that many blocks north, and then you're going to go across 2 blocks, And you can describe, because New York City is built on a sort of grid system, you can describe everything as in, I'm going to go that many blocks east or west, and then I'm going to go that many blocks north or south, and everything is an XY coordinate system. But if you're a radio amateur and your friend is over there, you put your antenna on a heading of 40 degrees, for example, that's going to point in that direction, and you know that he's 3 kilometers away in that direction, right? So you've got these two different ways of specifying another location. One is by XY coordinates, north and south, and the other is by a bearing and a distance.
Okay.
And polar modulation is like a bearing and a distance.
Yep.
And so I'm just trying to say you've got these different ways of looking, but looking at of describing a coordinate system, but the end result can still be the same.
Would the analog of the 2 blocks this way, 4 blocks that way, would that be I and Q?
Well, I and Q is the
I mean, that's a rectangular coordinate for
yes, you could consider it that way. Yes.
Yeah.
And then to get the angle, we divide Q and I to get the angle, the bearing, and then we take the magnitude to get the distance.
Yeah.
So that's what we do with polar modulation SSB. We split the audio into these two components, and instead of being I and Q components, we make these two components as an angle and an amplitude. So the amplitude we can then modulate onto the carrier, but it doesn't have to be an SSB modulation. It's just straightforward amplitude modulation. So all we're doing is modulation at a very low frequency, much lower than RF frequency. And at such low frequencies, you can make a very linear amplifier without too much trouble. Or you can use much higher efficiency techniques, as Aurora have done as Flex have done in Aurora, where you can use pulse width modulation techniques like a Class D audio amplifier uses to make very efficient amplitude modulation at the low frequencies. And then the RF frequency, you phase modulate. And what Guido's magic was in the USDX, he realized that he's got this 5351 synthesizer, which you give it a frequency, not a phase modulation, but you give it a frequency. And the magic was that if you every 10,000 times a second or 5,000 times a second or whatever update rate you're doing, if you give it the correct frequency offset, then that equates to a phase shift. If you calculate the frequency offset correctly, it's equivalent to a phase shift. So you can achieve phase modulation just by whacking this frequency around, the frequency that you're transmitting. You can achieve phase modulation. So in the micro SDX and in the QCX, QDX, QMX, we use this very tiny chip called the SI5351, which you give it a frequency and it just produces that output for you. It's a synthesizer chip. And this is an amazing chip. This costs about $1. It uses an I2C bus as its communication protocol. And you can keep updating this frequency very, very quickly. Experimentally, I was able to get up to 16,000 updates per second. And since you can make frequency updates equivalent to phase modulation, that's the way you do the phase modulation. The amplitude modulation, as I said, is just a simple matter of changing the amplitude of the RF envelope, and you don't need to worry about anything about sidebands or filtering or anything. And mathematically, this is exactly equivalent to an SSB signal at the end. But because you have avoided using a linear amplifier for the RF, you have solved an awful lot of complication. You reduce the cost, you improve the efficiency, and that's why in the Aurora, Mike will tell you, they use the same heatsink in the 500-watt Aurora that was used in the 100-watt in the earlier models of 100-watt non-polar modulation transceivers, because they've got this very high efficiency.
I just did a video. It's on the Flex Radio Enthusiast channel about the heat, and
Right.
I had something trip, and so I talked to Tony about it. Kilo 1 kilo Papa. Anyway, so the video shows we have in our test radios a couple of, I believe, the thermopiles sitting right above the power amplifier chips, because it's the things you do in the initial days, right? You'd be hitting it. Normally, you'd have a FLIR camera or something. Hey, are they getting too hot? So I was on 10 meters, I think on my demonstration I was on 40, but I was initially tripped over this on 10. And I had already plugged in the advantage of the Flex is we have all these meters that are available. Most of them are not on the front panel, but they're available for anybody to go look at and build your own meter panel. So I had done a meter panel to watch the pallet temperature, this 100-watt heatsink that we're running at 500 watts, and the temperature of the two power amplifiers. And so apparently we have, I don't want to give this away, but we watched them pretty closely in the prototypes. So after running 500 watts of FT8 carrier, because it makes a good demonstration, Mark, do you want to guess how hot those two, the ambient air temperature was 6 Celsius because it was my remote. You want to guess how hot those two power amplifiers were after 15 seconds of 500 watts?
Oh, only 15 seconds? I would guess less than 10.
Yeah, they were 3 degrees hotter.
Yeah.
Okay, so here you have 500 watts. I wouldn't dare do this on
Sorry, Fahrenheit or Celsius?
Celsius.
Yeah.
Okay.
Yeah, he said
They were up
6C.
to
My
8.
guess was 10C. Yeah.
Yeah.
Okay.
So after running 500 watt, I even did it later, just playing around for 15 seconds, 20 seconds, 30 seconds, 100% carrier. You could still put your finger on these things.
Yeah. Bonkers.
It's amazing, it really is.
Yeah.
Bonkers.
And this is why this technology has been used in commercial applications for quite some time, because you imagine if you have a 50 kilowatt broadcast station, you would much prefer that you don't have to dissipate 50 kilowatts of heat or pay the electricity bill for 50 kilowatts extra, which you're just throwing away as heat. And so in commercial applications, this has been done for quite some time. But I think that as technology has progressed, it's become more and more feasible to do it at the lower level and economic enough to do it at a much lower power level. Yeah. And that's why we start to see products in ham radio, which now include this type of modulation technique. So I mean, sorry.
I was going to ask you, so Flex's big selling point is efficiency, right? Power in for power out.
Wait.
Oh, and wait. Yeah, sorry. You're not telling me to wait. You're saying WEIGHD, mass. Yes, correct. Mass is also a benefit.
I wondered about that too.
Yeah. Sorry. My question to you, Hans, is the QMX also using similar modulation techniques. Do you have a lower current consumption on, X number of watts of mobile power versus a conventional linear transmitter?
Definitely, yes, yeah. You definitely get efficiency gains and efficiency benefits. And
so my battery, my 3 amp hour battery that I'm taking to a park with my QMX will last me longer on a QMX than it will on, say, what's that?
Definitely. It definitely will, yeah. And you look at my original, this was the prototype for the QSX transceiver, which is now an abandoned project, which was going to be a 10-watt multi-mode, multi-band transceiver. I'm showing you the back there, so you can see this big heatsink here.
Yeah.
And that was a 10-watt transceiver. Now, QMX Plus is a 5-watt transceiver. There was recently some discussion in our group, somebody who had doubled up the number of power transistors, and I've done it on my QMX Plus here, which I'm using for WinLink, and it now produces 10 watts output. So instead of having two transistors in parallel on push and 2 on pull, so you've got 2 plus 2, it's now 4 plus 4. It's a 10-watt transceiver, and these are 10-cent transistors. They're BS170 transistors in a TO92 package. There isn't even any heatsink. They just, we bolt them against the board, and that's sufficient heatsink. In fact, that's probably overkill. People saying they were doing these modification with the extra BS170 just flapping around in the air. There isn't even any heatsink at all. Having said that, the Flex have done it far more cleanly than I have done, and a far more ultimate solution than I have done, because my power amplifiers are operating in a switching mode, and so the power amplifier transistors are in a very high efficiency mode, but my amplitude modulation is still using a transistor in a linear mode. Whereas what they're doing in Flex is you're doing it the full thing. So they're also doing the amplitude modulation using high frequency switching as well. like an audio amp, old audio amps, it was all done
Exactly. Yeah.
with linear amplifiers. But the modern amps use Class D amplifiers where they're using pulse width modulation. So
Yeah.
Flex have taken it to the full distance. Whereas for me, on QMX, it was not so much about achieving the ultimate in efficiency, but it was also about the cost and the small size and the simplicity. There were so many other factors to work into it as well.
I would love to see what could happen, because I mean, you can get Class D audio amplifier chips for quarters, pennies,
Yeah.
not quite dollars, right? I would love to see whether that would work as your the power supply, the drain to your BS 170s. Have you thought about something like
Uh,
that? Is that even feasible?
I did think about it, and not for the original QMX design, but more recently I thought about it, and I did some research to try and find a suitable Class D chip, but I couldn't find anything particularly attractive in terms
Hmm.
of cost to performance
Bummer.
that I needed, and so um, I did not find any suitable chips that I would use for that.
Okay.
I think I would do it from scratch.
I've got to
Oh,
say that to me, like the whole concept of, I mean, how you did this and how you deployed the QMX, because the QMX first came out and it did digital modes and it did CW with the promise of single sideband. And
promises
in
it
quotes.
quotes.
it's kind of in
Well, I
quotes,
mean,
yeah.
it was I don't think anyone, at least I didn't think this. I think when I get a QRP Labs radio, I know I'm getting an incredible value for a radio that's going to really work. And like anything it does above and beyond what it does when you buy it is just like total icing on the cake, right? Like that's just it's a part of the experimental nature of working with kits and working with radios that are on the bleeding edge of, QRP design and stuff, right? But to me, like it's it makes me think of like when like when JPL is designing, some kind of craft to go to, like Mars or something, and they give it another like firmware package to do something like that they've discovered they want to do after it's there and it's
Yeah.
deployed. And I think about the QMX, like that was such a major thing. It wasn't like you were tweaking CW timing or I don't know, adding some little small thing. This was like a really major thing. You were adding a completely new mode into a radio that people had owned for over a year.
Yeah.
And deploying that was kind of like, it's like this remote, global deployment of this brand new feature. I think that's just a really, really cool thing. And
Yeah, totally.
I can't think of any other manufacturers that were able to build in that kind of functionality into what essentially is a firmware update. Um,
Well, that's the
so
theory behind what Flex does.
yeah, well, yeah, true. And like Hans has been pointing out, in a way it's kind of interesting. There are a lot of similarities between Flex and QRP Labs, even though they're on completely different sides of the spectrum, because Flex is going for, really high performance, contest grade, all these things built in with a lot of efficiencies. And QRP Labs is going for affordable, packable, small, lightweight QRP, and I think it's brilliant. I think it's brilliant you're able to do that.
I think you really got to one of the most key points of what happened over the last year and a half for me, because releasing QMX with that promise, which I could put as many quotes around this promise as I like, but as soon as I've said it,
Everybody's like, it's going to happen.
everyone's like, he's promised, he's
You're
promised.
committed.
And so the pressure on me was
Oh, I
huge.
feel your
And
pain.
the 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 risk involved was insane, right? Because I've
Yeah.
sold then by that time thousands of these radios, and everybody's expecting this SSB update to come. And I really only have to make that comment on faith because I haven't actually done it. It wasn't like I had a prototype or anything, and I just have to productionize it. I just haven't even done it, and I was just taking it on faith because of the fact that I'd seen what Guido had done with his modified QCX, which eventually evolved into the USDX, with an Atmega 328, an 8-bit CPU running at 20 megahertz. And I had faith that here I am with a 168 megahertz 32-bit ARM Cortex M4 CPU with floating point unit way faster CPU, much higher resolution ADC. I can do everything faster and more accurately. So I had faith that I would be able to implement SSB, but still the risk was huge. And it's like you said, when they send a firmware update to the Voyager spacecraft, they
Yes.
have to know what functionality that Voyager spacecraft has, and they
Mhm.
can't change it because they can't go out to where it is now and bring
Yeah.
it back and change something in
Mhm.
the hardware. And it was the same for me. I had thousands of customers out there that I have to make sure that whatever I implement is not going to require any hardware change whatsoever. And
Mhm.
so that was the kind of um, number one criteria, the number one constraint was there will be no hardware changes because I'm not going to tell these thousands of people how to change a capacitor value or how to add a resistor or something or even minor stuff. It just wouldn't be practical to do that. And so I was just looking up while we were speaking how many QMXs we're talking about. QMX and QMX Plus is now just under 14,000 QMXs and QMX Pluses have been sold in two and a
Holy
half years.
moly.
And, you know,
Can you imagine
that is a.
packaging all those? Sorry, let
And
me
so
interrupt, Hans. I mean, if you've
that
never
is a.
packaged like 4 items to send to somebody, I can't imagine. I know you have a team doing this, but that is so hard to do.
Mhm.
Yeah. Luckily, I'm not doing it myself anymore, like in the early days. Yeah,
Yeah.
I agree.
Now I'm really
So,
So,
curious. I'm really
I mean,
curious. Like, oh, go ahead. Sorry.
this constraint of not applying any hardware change, because there were so many times where I thought I'd really like to change the hardware. No, you can't do that. You can only do firmware. And so it was a really amazing thing. And to finally finish it and launch it in April this year was an amazing uh, landmark for me. What were you going to ask,
Can I
Tom?
Well, the
can
thing I
can
was
I
going to
share
ask.
really?
Oh, go ahead.
Oh,
Go ahead, Mike.
Thomas, go ahead. No, I'll be really quick. I want to share your thought because I think it's wonderful because Flex Radio's idea is identical, where we want the hardware to be updatable, like we're seeing now with RAID V2, WAV files, and that's the whole, exactly your idea, and because you don't want to, if possible, I'm going to get heat over this, to orphan your previous customers, but at some point that happens because of just hardware limitations. But I
Yeah.
think I applaud you on your thought process on that too.
Yeah.
I mean,
So,
yeah, as a hobbyist myself, I'm always in it more, not just as the business person, but as the hobbyist. And so, um, a business person might say, okay, if you want to add SSB, you have to buy this new hardware module and install it and this and this. But I kind of thought, it was a principle to me that I didn't want there to be any hardware changes,
Right.
and so make it all software.
well, and you wouldn't have room to put it inside the box because there's so much stuff inside the QMX. So, a dear friend sent me, bada boom, um, the low band radio, and I didn't know it was wired for 9 or 12 volts, and I couldn't get a hold of him right away. So I tore the radio apart, and I marveled at the fact that there's 6 circuit boards inside this radio, and they're so densely packed, and they're so tight to each other. There's a whole lot of mechanical space. I mean, some people might think, oh, well, we'll just put a dip header in here and we can add a board later. Yeah, no, there ain't room.
You can't.
And oh, and there's no room for a standard 0.1 inch dip header in there anyway, even for a jumper, because
Yeah.
it's so compact inside, right? Sorry,
The
Thomas, you.
challenge I set myself for the QMX was to make it the same size as the QCX Mini, and
mm,
it was just an arbitrary challenge which I set to myself. QCX Mini was already there with its board size and its enclosure size, and I decided QMX was going to be exactly the same size, no bigger. And
Well,
everything
and
just
there's
had to fit, whether it liked it or not.
and there's something to be said about utilizing your existing stock for future production, the extruded enclosures and the knobs and whatever too, right?
Sometimes we can do that, but the top panel of the QMX and the side panels is different from QCX Mini. So it's really only the bottom panel which is the same. The
Mm.
extrusion is the same, but I'm not using a custom extrusion anyway. Even with the volume I've got, the cost of making your own custom extrusion and the minimum order quantity for making aluminium extrusions is quite high. And so the way I do it, I use an existing extrusion which I can buy in bulk and then
Right.
slice up to the right sizes.
Yeah.
Tom was
Tom,
going to ask
S-
something.
So
Yes.
the thing I wanted to ask you about really has more to do with, I don't know, the business side and the structuring this, because I think you've definitely put a lot of pressure on yourself. It sounds like over the years developing QRP Labs, because you were like one guy doing all the stuff, for a long time now. You've got a team of people, and there is like this economies of scale that's allowing you to sell, tens of thousands of these radios. And it amazes me, like, that first of all, like, I've dipped my toes in the business of making kits back when I ran a nonprofit organization, and we had a small flashlight kit, which was basically like a jewel thief design, and it took a double A battery uh, and pumped it up so that you could like operate an LED in it for ages, and you could use a nearly depleted cell, and it would give you flashlight time, right? And we were using these in countries, and people would build them like in countries where kids could go pick up dead AA batteries. We're talking like really remote, rural and remote parts of the world that are impoverished. And we also just kind of sold these as like a fundraiser. And so I kitted up, and I had volunteers kit up these flashlights, which had probably about 14 different components or something. And just doing that was such a like a production for me, like, because you got all these little parts, and every time you get like a new batch of, I don't know, like LEDs or something, and you can't get quite the same one that you got before, and you're having to get another replacement one. Then you got to make sure that that one actually works and performs and has the same luminosity as the one before it. And it is such a complicated process, but I think kits probably do make doing manufacturing a little more accessible. As you're starting up. And I guess one of the things that amazes me about QRP Labs is you've really made radio accessible to everyone, because I tell people this all the time when they're getting into amateur radio now. I'm like, you're like coming at the best time, let me tell you, because
Yeah.
back in 97, when I was first licensed, my first radio, and I felt like I got a really good bargain on it, was I paid something like $700 at the time, US
Yeah.
dollars, back $1997 for a used IC 735 from ICOM, right?
Thomas, I
Um,
think you mispronounced back in my day.
Back in my day.
Yeah.
That's exactly right. And people complain today, they're like, "Oh, radios cost so much." And I'm like, "Look, let's take that $700 and turn it into like today money, and we're talking like $1,400, or I don't know, $1,200, $1,400 or something." And the barrier of entry used to be super high for anybody. And I went into the world wanting to be a QRPer. Even with my 735, I rarely moved it above 5 watts or whatever its lowest power setting was on those little slider switches. And but you've actually made like this whole family of radios that are super accessible if you want to build a kit, which there's appeal in that too, because there came a time when you
Yeah.
didn't see too many radio kits. Like there was like a lull in radio kits.
That's what got me into you in the first place. That's why I bought
Yep.
the U3s, because I wanted something to assemble.
It amazes me that you started out a company and did so, so effectively with such innovation, when you really are not coming from that kind of background at all. You're coming from banking and IT and all that. And I know that you've got the skill to do that. But it is really fascinating. I mean, like, the story of how your company came about and how you did things is really, really amazing. You've really kind of changed the world of QRP, which is the world I know best in the amateur radio world.
It is very, very surprising. I did not expect that it would turn out like this, and it's very, very hard work. I mean, I whenever I'm not with the family, I'm always with my face in email and trying to catch up and keep up, or reading something, and so it's very, very hard work. But it's also, I think, as you said, it's a good time to be in radio because the technology has improved quite some considerable amount, and we've got this manufacturing capability and components like the 5351, which we would never have dreamed of
Yeah.
previously. And so it's a very good time. And you have to, I think, be willing to be mentally nimble as well. And I think sometimes, you mentioned I'm not from a proper engineering background, and in some ways that can turn out to be an advantage, I think, because you've got a sort of more open way of looking at things, or
You
perhaps
don't know
you
your
don't know.
pre-established limits.
Yeah.
Right, you don't have any pre-established limits or any blinkers on, and you don't know what can't be done, so you go and try and do it anyway, and sometimes you find out it can be done. So it was also, times were very difficult during the last few years because of the semiconductor shortage
Yeah.
a few years ago, and you had to be really willing to change parts out or change. The original QDX had a AK5384, I think it was, an ADC chip which completely disappeared, and the factory that produced it caught fire in Japan, and it was nothing to
Yeah,
do with
we
the
know
chip
that one
crisis. It
well.
just
Yeah.
Asahi, what is it? Asahi K-High factory. They caught fire, and they decided that that chip was a low-end version, and they were only going to do high-end chips. And so I had to find a replacement. I found the PCM1804 by Texas Instruments, and you had to be quite nimble to sort of change around components and suppliers and new ways of getting things done. So it has been very, very hard work, but I mean, yeah, I'm completely amazed, continuously amazed by how things have gone, and how busy it's kept me over the last few years.
I
So
mean, I was going to say, if you ever have been to 4 Days in May, and I've seen Hans many times there in the past, and at Hamvention, and I just wanted to drop in and say hi, Hans, or whatever, and just kind of check in with him, and like that's almost impossible,
Nope.
because he always has
Yeah.
like a line of people just like with their cash just like ready to throw at his face, to get whatever it is he has. Because they know it's going to be kind of a cool project.
Shut up and
And
take my money.
yeah,
I'll
just
tell
take
you a funny story about that, Tom. When I was at Friedrichshafen, because each year I go to Dayton and then I go to Friedrichshafen in June, which is the big
Mhm.
Hamvention in Europe. And the first year I went was 2017, and I had with me this QCX prototype, and I was taking pre-orders. And at that point, I was still working on the firmware development and trying to finish production of the first 500 for the RSGB. But I was taking pre-orders at this Friedrichshafen convention for people selling QCXs. And I had one prototype. It was the only one prototype that ever existed that was on my desk. And I was demonstrating to people all the features of it. And there was continuously a crowd of people in front of my desk. And that first day, the Friday of the event, from when I got there at 8 o'clock that morning until when the last person left at 7 p.m. that evening, I didn't leave the table. I didn't even take a toilet break. I was so dehydrated from all the speaking. I didn't even
Yep.
take a toilet break. I
Wow.
didn't get anything to eat. I was standing on my feet there for 11 hours. And some people, they had their wives were coming with them to the convention or something and not really interested. And it was like, poor guy, I'm going to go and buy him some food. Some people were buying me coffee or chocolate to keep me going. And it was just the biggest crowd you've ever seen. And then on the second day in the morning, my tiny little 2 meter wide booth was opposite Kenwood, and they have this big shiny booth
Oh
with loads
no.
of staff and carpets and these massive like radios covered in color displays and buttons and everything. And on the second day, Saturday morning, before the show opened, the head of Kenwood, Germany, came over and he said, "What's going on over here? I couldn't even see what you're selling. What's happening?" And I said to him, "Here, take a seat." And I had a chair, I had one chair out there at the front. I said, "Take a seat, and I'll show you the QCX, what I'm going to start selling." And I went through my demonstration, which was by then so polished, I could, 5 minutes,
Yeah.
I could give that speech in my sleep. And I went through and I said, "It does this, it does this, it does the other thing." And he said, "Right, I'm going to order one. Here's my money." Bought one at Kenwood, Germany. So it was quite funny, but yeah,
That's
it's
credibility,
always
right?
really, really big.
Yeah, big
Yeah.
time.
That's credibility right there because okay, so he's a ham operator or something. He gets it.
Yeah.
Yeah,
Yeah, yeah.
yeah.
Glad
So
you
I've
said
got,
that.
can I ask two technical support questions?
Oh,
Oh, here we go.
Here we go.
Mark,
Where's
this
your
is
credit
not
card?
groups.io.
do we do tech support on here, Vince? Is this allowed?
I have a
It's
QMX
totally
kit.
up to you.
I have a QMX kit that I think I bought at FDIM some number of years ago. It is a revision 1 kit. Is this still worth building, or should I be upgrading to a newer revision?
No, it is perfectly fine to build that one. It'll work.
Bada Boom is a version 1 and Bada Bing is a version 4, Mark. They work.
Yeah, you won't be able to tell the difference.
Okay.
The PCB revisions I did were generally quite minor. And, sometimes, as we said, you have to change a component and a new one doesn't fit exactly the same. You change the layout for that. There were sometimes I changed things to make things a little bit easier. I remember on the Rev 1 board, at the power connector, the 2.1 millimeter power connector, the positive connection from that was very close to one of the nearby connections, and the distance was very small. It was quite easy to bridge a solder bridge across it when you were building it. And so in subsequent PCB revisions, I just kind of made that pad a little bit further away, so it was harder to make that mistake. They're very minor things, but a Rev 1 board will work. You won't know the difference.
Very cool. Then the second one is, I saw on your webpage about switch. Say again?
He did
There's
say
two
there. He
support
did
questions?
say no. He did say there's.
two.
He
I did say two.
We did approve 2.
The second one was, is this the switch mode power supply, or is this not the switch mode power supply? The website is unclear as to which ones I have.
Both are.
Like the QMX
Those are
webpage
both.
just says, click here for the switch mode power supplies, and these look exactly the same as the ones that are in the standard documentation.
Yeah, those are both the switch mode power supplies. The QMX has 2 switch mode power supply boards.
Okay.
The one you see, the one with the big, the one with 2 big transistor looking things is in your left hand, if I've got it correctly.
Yep.
And that's the 5-volt regulator board, which also has the soft power switch. So on the QMX, you can press the on button to switch it on and off. It doesn't have a toggle switch it has a soft power switch, which is also reverse polarity protection, and that's the 5-volt supply. And the smaller board, with only the one large transistory looking thing on it, is the 3.3 volt board. So they're both boards that are in a QMX.
Okay. The website made it sound like I could add it on afterwards, or it was a separate thing.
No, they're already included in the QMX kit. I don't think I have any boards lying around
these
here.
Are replacement boards for the ones in.
Those are replacement boards, yeah. On the ordinary QMX kit, when you get it, you break the board up into many different pieces. As you said, there are 6 boards inside, and 2 of those are the power supply boards. So those are only replacement boards for people who have damaged them somehow.
That's the only tech support I needed. Thank you.
Everything is forward and backward compatible, so that you can use the current boards on the previous on the Rev 1 board or anything. It's all compatible.
Mm-hmm.
Well, now that Mark has broken the ice.
Oh no!
No, here's a design question, and here's something I genuinely don't understand. There's 4 BS 170s inside the QMX, right? Do I have that right?
Yes.
Yeah, okay. And so you look at these things from the top, and you see 3, 6, 9. You see like 12 leads, like 24 leads, and they're held in place with a great big a washer and a bolt through to the board, and the washer serves as a heat sink. But when I look at, and so the radio puts out 5 watts, upwards to 7 watts, depending on how many volts you put into it. I'm going to run mine at 9, even though it's wired for 12, because I don't want to hurt it. But when I look at the BS 170 spec sheet chart, it says it's a 350 milliwatt transistor capable of dissipating 350 milliwatts. So 350 milliwatts, 700, 1400 milliwatts of those 4 transistors. How do we get to 5 watts? That's the part I don't get.
To start with, that's dissipation. So that's the heat dissipation rating, not the RF output. So if you had something that was 90% efficient, if it was 90% efficient and you're producing 5 watts, then you'll only be dissipating just over half a watt as heat, because you're 90% efficient. And if you've got 4 transistors, they'll each dissipate 125. The second point is that 300 is not actually correct. There were different versions of the data sheet. I'm looking up the modern one now.
Oh, yeah,
The
the one
heat
I've got on screen in
dissipation
front of me
is,
is a BS170D. Yeah, okay.
yeah, so it's 830 milliwatts is the heat dissipation rating of the ON semiconductor device that we
Dang.
use.
So 3 watts of dissipation across the 4 of them.
Yeah, just over 3 watts of dissipation. Yeah.
Okay.
But as I said, that you have to remember that's dissipation, not RF
Yeah,
output.
of course.
So,
Yeah.
and the more efficient you can make the operation, the less heat dissipation will be. We find, of course, the efficiency goes down at the higher frequencies,
Right.
and so you have to bear that in mind. But that's how it manages it.
All right.
You
Okay.
mentioned doubling up the number of BS170s. Do you
Yeah.
have to change anything else on the board?
No, nothing. And I tried this. Well, actually, having said nothing. So in order to get double the power output, and this was a Dutch guy, PA0RDT, Roloff, who came up with this idea. And if you just literally just solder in place piggyback on the existing transistors in parallel, you get an efficiency improvement, a slight efficiency improvement, and you also get a power improvement. But if you really want to double the power, you need to use the different transformer ratio that you would
Yeah.
use if you were winding it for, if you were, you can wind it for 9 volts or you can wind it for 12 volts. And if you wind a transformer for 12 volt operation, it's a 3:2 ratio transformer, whereas 9 volt ratio is a 3:3 ratio. So if
Okay.
you use that 9 volt transformer ratio, 3:3, but you power it with 12 volts, you get out this 10-watt power output. Or you could do what he did, where he used the standard 12-volt transformer. He put the double transistors and he just increased the supply voltage to 13.8 or something like that. And he also got 10 watts out like that. But there were no
Okay.
other changes, no other component changes. Very easy.
So I want to be able to run it on 14.2 volts max because that's the output of my batteries. And so you say do the 4.2 or the 4:3 ratio and double up the
3:2
transistors?
ratio. Double up the transistors, keep
3
the
to 2.
same 3:2 ratio, and then
Okay.
double up the transistors, and then you should be able to increase the supply voltage without
Okay.
burning out the PA transistors.
Okay. I'm less concerned with the more power, although that would be nice, but I am very interested in being able to run it at, straight off of a battery voltage.
Right.
Yeah.
The
Okay.
easiest way, if people want to reduce that, is just put some diodes in series, and each diode you put in series will drop the voltage
Yeah.
0.6 volts. It's not very
And drop your
efficient, but it
efficiency and
works. Yeah.
burning energy and blah, blah, blah. Although I guess I'm
Right.
doing the same thing if I'm transmitting 10 watts. But
Well, I mean, Mark, you could also consider bucking it down too, right?
yeah.
The problem
but
with
then that's
bucking it
another
down
thing.
is that the problem with all this is your batteries will start off at 14 volts, and then the
Yeah.
battery voltage will come down and down and down. And if you've got diodes in series, then they've got a fixed drop, so your supply voltage to the radio is coming down fixed. If you've got buck converters, at some point they won't work down to 12 volts if you're not more than a certain threshold above 12 volts, or they have some changeover point. And so, yeah, power supplies are a tricky business.
Yeah.
But the most important thing is people shouldn't push for the absolute maximum power output. It normally doesn't result in the best output efficiency or the best spectral purity or anything.
Yeah.
And it makes very little difference at the other end of the contact in terms of S points. If you gain a few hundred milliwatts of power output,
Yeah.
and you think I've arrived because I've managed to get 5.8 watts out instead of 5 or something, the actual difference in terms of S points at the other end, because it's a logarithmic scale, is very, very small.
Yeah, it's really
Oh,
quite
that's
bugger
such a
all.
hard lesson to teach.
Yeah.
Yeah, and so I go back to my earlier statement. Both these radios are wired for 12, and we've heard my stories of success or lack thereof of winding toroids and binocular cores. So I'm not about to redo binocular T501 to wind up for 9. I'll just happily run it at 9 and and work with it that way.
Yeah,
Uh,
I've got to be honest. Like for me, I like radios in that form factor. I like running them at around 9 watt or 3 watts of output power, which is usually somewhere around like 9 volts or whatever. I've always found that super effective. Like I've never,
And
I mean, I do activations with 100 milliwatts
yeah,
in
but
CW. So
you've got the 10 dB of gain of using CW versus sideband,
well, he's got
right?
the
I
10
that's
dB
true.
of gain of being on the eastern seaboard, where
and of
he's
being
within a
Thomas.
stone's throw and being Thomas. So he's got effectively 30 dB of gain. So that 100 milliwatts is almost like 100 watts for him.
I
Thanks
know,
for
man.
making it sound
You're
like it's not
QRO.
skill.
And
Um,
if you're using sideband, then by the way, I hope I still sound okay. I've stopped using my earpiece because the battery in the phone has gone down to 5%. I started
uh-oh.
off at 100 when we started this recording. So I've had to plug in the phone to charge it and take out the earpiece. And so I'm now on speakerphone. So I hope it sounds reasonable
You're
still.
just fine.
It
You're doing
works.
great.
What I was going to say is if you're using sideband, the QMX has all these features like controlled envelope single sideband. And controlled envelope single sideband effectively more than doubles your effective average power output. And you've also got parametric equalization, compression, you've got
Yes.
all of these features. So you get far more benefit from trying to optimize and use these features like compression and parametric equalization. You get far more benefit from trying to optimize that than you do from trying to squeeze out a few extra fractions of a watt.
Yeah.
By adding some transistors or worrying about the
Yeah.
supply voltage for sure.
Yeah.
And Bob
Like I said,
Heil,
I'm less interested in being able to increase my power output as I am in being able to use my battery voltage directly.
Yeah.
right,
Yeah.
Yeah.
right. Bob Heil taught us all that to restrict our voice passband on transmit to those really important areas of that passband, roll off everything below 500, roll off stuff give it a little boost around 1,000 hertz or
Yep.
wherever the center is on your voice, and you can increase a little bit of sibilance, but not very much above 3,000 hertz, because you're outside the audio passband anyway of most radios. And I saw that demonstration live, and it blew me away to see it live. Um, it would be awesome to see the QMX radios on the Heil Ham Radio DSP settings website, so that those of us don't have to go and re-engineer it and figure it out. But maybe I'm going to have to do that now that you've said that. I'm still 20 pages into the manual. I've been using it for CW only up to this point. I've had it for less than a month. It's fascinating radio. Hans,
What I did with the QCX, and I tried to carry over into the QMX, was I tried to make it so that at the most basic, you'd just be able to sit down and use the radio without thinking any further about it. So when you picked up a QCX and you plugged it in and everything, you've got a tuning knob and a volume knob and a key, and you just operate.
Yeah.
But if you wanted to get into it, there's a lot more detail in the menus. You've got the split VFO, RIT, you've got memories, frequency
yeah,
memories, message memories, you've got all sorts of other features. You've got all the built-in test equipment menus in the QCX even. And I tried to do the same thing with QMX, tried to make it so that at the most basic, you just use the radio and you don't even have to read anything. It should be quite simple. But there's a lot of extra things to look into if you want to go into it deeper and start to get more out of the radio.
yes,
And with SSB, it's very hard to avoid that you've got to go in and do something because there are so many things. And when you get to it, you'll find there's a parametric equalizer, so you can specify a boost or an attenuation in the low part of your voice and the treble part of your voice, and you can therefore adjust in these three bands, the center part, the bottom, and the top. And you can adjust everything to get the shape of response that you want. But it'll be different for different people or different desires, applications that they have. Some people want maximum DX punch. Some people want to sound most natural on their local net. So it's different, depends what people are looking for. And
yeah.
so, yeah.
Yeah, indeed. It's there's so much to it. And so if any of the things I've said haven't turned into a commercial for QRP Labs, and telling people to go and buy a QMX, I don't know what is, because I just think it's
Exactly.
super fascinating. Hey, Hans, tell me, is there anything coming up next that you wish to share with us?
I learned my lesson on that, Vince. I did. And the amount of mental anguish I went through with the QSX when everybody was asking me, when's it coming? When's it coming? When's it going to be ready? And it got really, really stressful. And so in the end, I made a decision. Any future radio, I'll just announce it when it's ready. And I did that with the QMX at the Dayton, my FDIM speech in 2023 at May was about the QMX, and it was a surprise to most people. It wasn't a total secret. I confided in a couple of people, but it was a surprise to most of the people. QDX was also a complete surprise to people, and I kind of decided I need to operate that way for my own mental health, and so I tend to confide in it. I confide in a few people what I'm working on, but I don't make any public announcement until I'm a little bit more ready. But generally speaking, there's still an awful lot more that I want to put into the QMX, and the firmware on the QMX, it has 512K of flash memory program space. I'm using about 40% of that at the moment. On receive,
Oh, wow.
the CPU utilization is roughly 40% CPU utilization during receive. So there's a lot more things that I could imagine wanting to add to it, like some kind of simple tuning indication, like a sort of spectrum display on the screen in very minimal way, because it's only got a minimal screen. I want to incorporate the full functionality of the Ultimate 3S with all those beacon modes and everything. I want to incorporate that into QMX as a kind of virtual U3S, so you could do everything on there.
Nice.
I want to incorporate the basic programming language for scripting, because QMX Plus has a lot of GPIO pins, which I've exposed on pin headers, because you're saying how small QMX is, but QMX Plus has got a lot more space inside. And
Yes.
people have been developing things like there's a project for a tuner, ATU tuner, an auto tuner, a speaker, and a battery. And there are all kinds of things that you could control with it. And those GPIO pins are exposed on pin headers. So I want to make a sort of basic programming language scripting tool to be able to control all of those and customize the radio and the user interface if we want to. And so there's a lot of things that I want to put into QMX and have been dreaming of putting into QMX that are firmware stuff. So the product will continue to evolve, and those firmware updates are extremely easy to install.
Yes, they are.
The QMX in firmware update mode just looks like a USB flash drive on your PC, just connected with a USB cable, and then you just drag in the new file, and that's it. There's no more to it. And so there's a lot more I would like to do for that. I do have plans for the whole of the next 2, 3, 4 years of development and products, and well, I'm not sharing those.
Well, Hans, at any time, if you'd like to come back and talk with us about something that's coming up or come and hang with us, you are most welcome to do so.
Yep, absolutely.
Thank you.
It has been
Yeah,
an
I think that, to me, that the process, everyone thinks that this is a very technical job to do, but it's, to me, also a very artistic job and a very creative job. And if you have a lot of stress because of people demanding stuff from you, it gives you this kind of writer's block. And that's what happened to me with the QSX. You end up not being able to face looking at it when you come and sit down in the morning. And so having a free mind, or letting your mind go to wherever it wants to, is, I think, important, because it is kind of quite creative and artistic as well as being very technical. And so
that's a wonderful way to put it.
I'm looking at the documentation, and you show the different layers of the board, and there is definitely a beauty and art to board layout and design, and this thing is just amazing at how you squoze so much into such a small area, but it's still squoze. Yes, it's a
that's
verb.
a new word. I'm going to remember
Squozed
that. I like
squoze,
that word.
yeah, so much into such a small area, and how cleanly, and I mean it looks chaotic, but there's no like unnecessary via up and over and tracing all the way around, right? It's like
Yeah.
everything is still very efficient and very direct.
PCB layout is a really interesting topic, and there are a lot of things to learn. And for EMI performance, it's very important to have a lot of ground planes to take care of the
Yeah,
return paths of the signal. And so I watched an awful lot of YouTube videos. There are some really, really good channels which are by very, very experienced electronic engineers with regard to PCB layout, talking about how you want to minimize these cavities, how you want to minimize the length of any sort of signal paths which don't have an adequate ground return path.
yeah,
And so actually for me, my favorite part of the product development is the PCB layout, because it
yeah.
takes some
Me too.
weeks and it's all just moving stuff around and connect. And I never ever use the auto router because it does a
Oh,
terrible job. It absolutely is like a joke. You
yeah,
don't get things to be packed close together, and neither do you get a good um, EMI with lots of ground plane and everything. So I stitch all the ground planes everywhere. I try to make sure that there are vias between ground planes very close to where signals change layers, so that you don't
yep,
have any issues with return paths not joining up. And I spend quite a lot of time moving things around to try to optimize those ground planes. The
yeah.
board
It
layers
shows.
the boards I'm using now on the QMX and on the QMX Plus are 6-layer boards, and 2 of those layers are on the QMX and the QMX Plus are completely unpopulated with any traces. They're just pure ground planes.
Yeah,
But even the others, both top and bottom, I mean, I see a lot of multi-layer PCB designs where even some of the big manufacturers, I'm not going to drop any names because I don't want to annoy anybody, but you look at the boards and they've got traces on the top, and then they've got ground planes internally, or supply planes internally. But I put ground planes on all of the layers and
yeah,
stitch them together, so I take no chances or risks at all with it. On the other hand, it can make it hard when you're soldering a component which goes to a ground pin and it's got 6 layers of ground that are absorbing the heat out. And so, but yeah, I love doing the boards, and I think probably I have my own kind of signature way of doing the bends and everything that would make them recognizable.
yeah.
It's good fun.
Hans, it's been a delight having you here. Is there anything we should have asked that we didn't?
I can't think of anything you shouldn't have asked, which you didn't. No.
All right.
There are some things you did ask but shouldn't have. Tech support questions.
Oh, how's QSX coming along?
Mark, he did say tech support
that
questions.
That's right.
That was a really, really good day earlier this year when I was able to write that email saying the QSX project is now formally cancelled because QMX. This is the other thing I don't think we covered, which we've talked about the efficiency of polar modulation, but I think the benefits are not just efficiency, but also higher performance. The RF engineers, they spend years and years trying to turn any data sheet. You open up a data sheet of any transistor or anything, you don't see nice straight lines. You see curves. But what you want in an RF linear amplifier, you want straight lines. The output amplitude should be proportional to the input amplitude over a wide range of signals as a straight line. But you open up the data sheets and you just don't have straight lines, you have curves. And an RF engineer will spend years and years trying to make those curves as straight as possible, or doing all sorts of things like pure signal, where they're doing adaptive measurement of the non-linearity and pre-distorting it back in. And all of this stuff is very, very difficult to do. But when you do polar modulation, because the amplitude modulation is happening at much lower frequencies where you can do it very, very precisely, the RF amplifier doesn't need to be linear. You don't need to try and make straight lines anymore. You just want a perfect switch if possible. And so you get higher performance for a lower amount of effort. And I think that's why something like QMX outperforms the original QSX idea in terms of intermodulation by at least 10 dB. Even though it doesn't have a linear, it's just doing all these crazy DSP techniques. And so I think this is a real sort of benefit of polar modulation, the potential for much higher performance, as well as lower cost because of less heat sinks, more efficient transistors, but also lower development time. If you think about QMX, I was able to do the SSB in about 10 months of hard work on QMX. Just me, just some idiot sitting here. I'm not an RF engineer. I'm not a team of RF engineers who would normally be designing this stuff. And yet it comes out with super high performance. And so I'm very excited about polar modulation. Mike and I have talked about this a lot, and I have a lot of respect for what Flex have done with Aurora, and taking on such a big new technology like that in such a big way with a big product is an amazing thing to do. So we've had a lot of chats about this. I think it's just amazing, the future potential that this holds. So
that's
ham operation on RF engineers, what I've been taught, is really tough. Like we talked in the beginning, that envelope elimination and restoration, or polar modulation, has been around for a long time, since 1952, when Leonard Kahn developed it. And then commercial world is great because, hey, we're operating, I don't know, plus or minus 100 kilohertz on this frequency. Finger quote, easy enough to do. But hams want transmitters that cover from, I don't know, 1.6 megahertz all the way to 54 megahertz in a single box. And that's the curve nightmare that you talk about, right? Okay,
Yeah.
we get great power at 20 meters, but and it's taken us an incredible long time to make it incredibly linear in the A and the AB world. Pretty good anyway. And this is why the commercial version of this is so hard, because we had to cover all the bands.
Yeah, even if you can straighten out these curves on one band, you go to the next band. How many octaves we want? We want all the way from below 2 megahertz to above 50 in one box, as Mike said. It's a terrible challenge. And
Can you do this for 2 meter and 440 as well while you're at it?
And don't forget 1.2 meters.
I don't think so.
Yeah.
It was hard enough to get 200 watts. Yeah, go ahead, Hans.
I have very little experience above HF, so I'm staying to HF for now.
Well,
Tony said it was hard enough to get 200 watts at 6 meters because of the speed required.
Yeah. Basically, the switching speed gets harder and harder to achieve. So you really want to achieve this kind of high efficiency, you want very fast switching. So you want the transistors to be either off or on. An ideal transistor, when it's off or when it's completely on, like a switch, is dissipating no power, is wasting nothing. So it's 100% efficient. But you waste energy every time you switch. And of course, if you're switching at 50 million times a second for 6 meters, you're wasting an awful lot of energy each time you switch, if you're not doing it as fast as possible. And it gets harder and harder to do that the higher up in frequencies you go. But I don't know that I'd say that it's impossible, Mike. I think it gets harder, but I don't see it in my near future.
That's the impossible part I meant, because if you let it out, when are we going to get it?
Hans, in wrapping up, thank you so much for coming to sit with us today. Thank you for asking Mark's tech support questions. I think Mark's next product that he can develop is a power supply that delivers good power as the battery voltage drops down, but a consistent output. That's just my 2 cents worth. We greatly appreciate you coming along with us today. So from all of us here at the Ham Radio Workbench, 73.
Thank you very much for inviting me, Vince. It's been an absolute pleasure. Thank you. 73.
7 threes.
Be good humans.